Hello, everybody. Good morning, good afternoon, good evening, and let me introduce the keynote speaker. It's Professor Dr. Vladimir Trikovic, and the presentation named Big Data, Internet of Things and Health. May the force be with you. So, please, Vladimir, the screen is yours. No voice, sorry, no. We can hear you.
Thank you for the introduction.
Okay.
Can you hear me now?
Yes, great.
Well, hi to everyone. It is a pleasure for me to be there, even virtually. I hoped that this will be my second time in Kaunas, but unfortunately, the COVID situation has stopped me from coming there. Anyway, I'm sure you're having a very successful conference. So, as you already said, my topic for today is Big Data, Internet of Things and Health. And can you recognize the second sentence in my title, May the Force be with you? Do you know where it came from? I cannot hear the audience. I hope they have comments on the Slido screen. So my agenda for today, I will start with why, then I'll try to explain how, and then I will speak about what my group is doing. And I will also tackle the challenges and the possible solutions of the challenges in this topic. So if you know the first sentence, you will know that it is from the very famous movie or a series of movies, and this is the map that illustrates that series of movies. It is the Star Wars universum, and all the happening in all the movies is happening in this region, and the universums are very important in our world, in the science world, in every science world. The universums are actually the people networks. So why are the people networks important? Well, I will just show you one picture from one of my papers from last year. We analyzed the cooperation between authors with the affiliation of different countries about the topic on wearable technology and the usage in connected health. And if you see the more dark the color is, it means that they have more publications. And in the world of science, publications are very, very important. So the dots represent the countries, and the line between dots represent the actual cooperation. As you can see, and we have done this on many topics in the health, in the ICT in health or connected health area. And as you can see, the dominant countries and the dominant corporations are the ones that are basically most successful in then patenting those results and commercialization of those results. So the first point would be, if you want to be successful, not only in science, but also in commercialization of the results of your science, you have to go international. You have to make cooperation. So having that in mind, I would like to present my universe. I'm working, so these are just the representative or the leaders from different groups in different countries. So as you can see, in the last 10 years, I've been working with people from my region, that is Serbia, Slovenia. I come from Macedonia, so Greece, Croatia, Bosnia and Herzegovina. But I'm also working in Bulgaria, but I'm also working in the wider European region with Ireland, Slovakia, Czech Republic. And the last guy here is coming from Kaunas University of Technology. I think that is my host today, my virtual host today. I didn't have a pleasure to actually work with him. We only met twice on different meetings, The first time we've met was in my country, in the city of Ohrid. And the second time we've met was in Kaunas. And I remember a fruitful discussion. And I think that I wanted to point out why are these meeting in persons important now. Nowadays, there are virtual meetings, because that's how you make first contacts. And sometimes those contacts, those conversation would transfer to actual research and an actual publication, actual results. Sometimes they will not, but you have to work on your universe. And then my local team, I have 4 PhD students because the last one just moved out, and 2 master students in my core team. I'm also proud of my former students. Some of them are now in Australia, some of them in USA, some of them in Switzerland, but I also do collaborate on the local level. And I'm very proud that some of the things that I will mention today, some of the scientific work that I'll mention today was actually, parts of it was commercialized in different companies. And those companies are also shown on the slide. So we've talked about the universe, but the Star Wars movie will not be the Star Wars movie if we don't have different technologies or different starships flying around in them. So why different technologies? Why are those important? Well, actually, they create both possibilities and challenges. And what are the technologies that I would like to mention, or I will tackle during my speech? Well, those are the technologies of big data, IoT, machine learning, and blockchain. And I hope that you can see still my screen. Do you see this Mentimeter website? If you do, I would like to ask you to go to Menticom and enter the code 3737863 and answer to the question, when I mention the big data, IoT, machine learning, blockchain, for any type of their possible usage, but especially for their usage in health, what possibilities can you see? If you go to the Menticom on your mobiles or on your computers, whatever you have with you, you'll be able to enter three terms, 3 phrases, 3 words. So please do so. I will give you just a few seconds for doing that. And from my point of view, technologies are like tools. They can be used both for good and bad, and it's really up to the one that implements those technology in certain field to consider how he or her is using them. So I only have one answer so far. I hope so. Two. Okay, that's great. Let us wait a bit more. For example, big data is making possible to have so many information in health domain at one hand, but the one will think that the work of the health specialist will be much easier, but at the same time, the big data is creating practically the overwhelm of information for the medical specialist. So you have to deploy techniques that will actually filter useful from not useful data. The same stands for IoT. IoT enables continual monitoring of different vital signs, of different environmental signs. So it can help in creating the better understanding of the state of the physical and medical, psychological state of the patient, but then you have to interrupt those data. Machine learning techniques are very useful because, as I'm sure you've probably know, there are many machine learning applications that actually can detect some medical anomalies from the picture, for example, or can predict conditions of the patient in the short period of time. But then they're not very useful if you cannot elaborate on them. And the blockchain is good for enabling trust. So, for example, I'm sure you have this COVID tracking application. It was not successful in my country. Why? Because people were afraid that the government will check on their locations, on their contacts. But if you put the blockchain layer on it, you can enable the status or the message that will inform all the users who has checked and in what context they have checked their own data. So these are the possibilities. And what about challenges? So now I have the next question. I will wait for I will wait for few seconds for your answer. I only have 4 people. I hope that I'll have at least 5, 6 answers, so we can then discuss results later on. So I've collected the data, and I'll go back to the presentation. We will come back to your answers. So then, if we talk about different universe and different technologies, then why health? Why health domain? Well, health is more than just physical condition. And it is important to think about health in terms of multidimensional activities, in terms of your mental health, your physiological state, in terms of what you input to your body, both from the perspective of food and the perspective of some medication, if in the case you're in some chronic condition. And it is also very important that to consider the period of the time or the time intervals when you rest. So the combination of all this data, or of all these let's say activities, create your health condition. From the perspective of computer scientists or computer engineer or of data engineer, that means that you have to combine and annotate all these different data streams that have different nature and then that have different characteristics. So if we talk about networks, and if we talk about technologies, and if we talk about particular domain in which you can apply those technologies, so how you connect all those 3 things. So I will talk about three subdomains of this huge research, possible research. I will talk about connected health, translational medicine, and ambient and assisted living. So connected health is practically way to gather all the possible data and to put in practice all the possible technologies in order to provide better treatment of the patients, better medical care, but also better well-being of the users. Once I remember that once I was on this meeting and 10 scientists, we were sitting together and just trying to define the term who is the beneficiary of the connected health and it was the discussion that lasted almost 2 hours, because it is not just the patient, it is not a health person that is in a good health. So I think that we end up with the term citizen. So connected health is actually trying to change the way we are considering the benefits of healthcare and the usage of the technology in that domain. But then if you, so just imagine all the possible technologies put in the healthcare. And if you just try to imagine that, and then you will see that you'll have multiple data coming from multiple sources, and you have this big data accumulation. And most of those data would not be even structured. So it will be in handwritings, for example. Only 20 of those data will be structured. And then if you analyze those structured data, only 1/4 of that data will actually be useful for any type of research. And research is very important because research put the ways, the protocols of the usage of that data that enables learning health systems that can adapt to the needs of the users both from the perspective of healthcare professionals and both from the perspective of healthcare beneficiaries, like people, citizens, both for the medical treatment and for improving the lifestyle. So this only means that we have not even tackled the possibilities of those systems. And why is translational medicine important? Because it provides a bridge between research and clinical practice. That means if we manage to find the use of all available data and all available practices and the proper use of all available technologies, then we can actually make these healthcare systems that learn and then adapt to different needs of different stakeholders. And how can we do it? By data integration. When we spoke about data, we have to integrate not only data from healthcare institutions or from let's say from hospitals, but we also need to integrate data from private users. For example, the holy trinity of data in the healthcare is data about how you feel that can be verified from the hospitals because they have validated information about your health condition, but also what you eat, how much do you train, and what kind of treatment are you using, and how often, and is it regular or not. So you see, even in this basic case of collection of the data, you still have many data sources, and some of those can be validated, and some of those have to be trusted. And then you have to integrate those data and make them interoperable, so you can actually put some machine learning algorithms, for example, to work with them. And only after that you have possibilities to create knowledge discovery. And just imagine how this issue of making the translation in medicine becomes even more complex if you put, for example, genomic data or environmental data, or genomic data prediction or environmental data prediction in it. So it is a quite a complex situation. And is it possible to somehow organize to work on that problem? Yes, it is. And this is well, let's say very high level overview of the work we proposed. If you check this reference put on the bottom of the slide, and search for the people that are put there, you will see that it is a combination of engineers and medical specialists that are talking about different types of analysis of data and different ways of validation of the data. What we have concluded, that it is very, very important to provide a proper training, because and we are very happy to see that in the last years we have a few initiatives about this academic courses curricula that is creating the professionals that will have enough domain knowledge from the medical perspective, from healthcare perspective, from well-being perspective, and enough engineering knowledge. Because what is happening in the moment, we are trying to make possibilities from two different universe of IT engineers, data scientists, academics, and universe of medical specialists to talk to each other. And I think you can imagine that is not an easy job. And that's why it is obvious that we need to create a new type of curricula. And once we go to any of those two domains, so if we just want to apply some of the specific medical domain knowledge to something that would be typical IT topic, the things are getting a bit clearer and more easy to understand depending on the universe you are belonging in. So in this particular case, I choose this general ambient and assisted living application. What is that? Well, that is the system that collects information from different sensor networks, and in some fog cloud, nowadays even edge domain, it is collecting them, processing them, and then provide useful information from healthcare providers. So you have different set of problems put in different set of layers, and you practically apply some typical machine learning paradigm with data from a specific stream. So in this specific case, you only need specific domain knowledge to understand the data streams that are coming from different sensors. So what is important from those data streams, and then and then you need additional information to annotate the achieved results in order to be able to better predict useful information for your end users. And this is, let's say, easy to understand if you're IT engineer. It is, on the other hand, it is not really easy to understand if you're medical personnel. When we presented this approach to different hospitals, for example, and you will see in a little while what I'm thinking about, we received tons of questions. Most of them was how I will be able to use those predictions if there's no way to explain using the evidence-based medicine approach why those decisions are made. And so that is why it is important to cooperate. So if that happens, what is possible? So what happens from my personal network? So this is quite old research. It is from 5 years ago, almost 5 years ago, and this is connected health algorithms. What we've done here, it was a very basic thing. We put a lot of wearable sensors. We create a sport tracking application. We provided free usage for them, and with the help of the company, of course, because you need to create a support for the end users. You need to create nice user interfaces. And so in few months, we managed to have almost 500,000 users worldwide, and we collect information about their sport habits. Then we try to categorize different users by the type of activities they are performed, the environment in which they are performing, because for our users, we know their location, we know the let's say the weather prediction in their location. And by using the collaborative filtering techniques, we try to give recommendation for the best activity for any of the users, having in mind their goal. In the first phase, we use the sport-oriented goals. For example, you want to run 10% faster. Okay, out of those 500,000 users, we'll find users that are physical, that are similar to you from the perspective of their sex, their weight, their sporting habits, and their results. And we will check how many of those users have already achieved the goals you want to achieve. And then we will just transfer or try to create a path how you can go from your sporting habits to their sporting habits. And we believe that if you manage to follow their sporting habits, then you will achieve those results. Why? Because you're in a similar shape, you have similar height, you have similar weight, and if you even live in the similar regions or so the similar attitude, the similar weather conditions, then we believe that you have found you the positive examples that you simply have to follow. We would even able to go one step further. So, for example, if the recommendation for you is to have, let's say, half an hour of running every second day and then sprint training once a week, we were even able to provide you with the possible dates for your and timing for your training, having in mind your previous activities, where and when do you have them, and having in mind the weather prediction in the area you're currently in. Then we were even able to create virtual runs. So for example, you can run with the best version of yourself from your previous activities, or you can match your results in virtual way with the actual activity of some other users that is close to you in that path of success. And this was just with information about your activities. Just imagine if you can add the information about pharmaceutical treatment or some medicine that you have, or information of what do you eat and how do you eat. And well, this was successful. We managed to, we are not following this path anymore because a few years ago, two years ago, so after 3 years, we managed to sell the data or sell the application to the healthcare provider in the north of Europe. But although the system seems to be very easy to implement and seems to follow the paths of the evidence-based medicine, because our plan was to use it for example, for diabetes, because diabetes treatment or pre-diabetes treatment is very related to the activities levels these patients are having, and the way of what kind of intake in terms of food and medicine they're having. So if we manage to put the food intake and the medical intake into this approach, we believe that we could even help fight with diabetes. But this was not an easy job. Even only if we then in the second phase we try to create recommendations for weight losage, for example. So if you want to lose 1 pound or if you want to lose 3 kilos, so what kind of activities you should have performed. But then you have to have in mind so many information from medical domain. For example, when you have to execute some activity, is that activity actually having positive or negative impact not only on your primary goal, and that is, for example, losing weight, but on your physical condition, because it is not that simple. You cannot just ask someone to run, and while running, you notice that the heart rate is going above normal, and above normal for a very long period of time. Then you risk serious heart condition for that user of yours, and that means lawsuits for the companies. That means possible tragedy, and that is not what a proper research would mean. Then even if you have activities, when the activity will actually reflect in your data, and you're collecting data from wearables. So then you have to model that, and then you have to model the different goals, and that are let's say determined by the end users, but also the different goals that you have to derive from their previous activities, their habits, and their specifically specified goal. So for example, if someone that has a possibility for a heart condition wants to lose 3 pounds, you have to search through your database to find similar people, and then you have to check whether those similar people have managed to find out the good set of activities and the good set of timing. So then you realize that You cannot simply use the crowd sensing data in a way, but you have to put some expert knowledge from the professional trainers, from medical conditions, and so on and so on. So the situation is becoming more difficult and difficult, and then you say, well, maybe we want to not to use all this information to predict data, but maybe it is better for us to optimize the way we collect data and to work on the sensor input. So this is another example, and this is the example of a mobile wireless monitoring system for pre-hospital emergency care. This was actually done within the NATO project. And the aim for that project was to equip soldiers on the battlefield with some basic sensors that can be easily connected and not connected. So in the case of special fight conditions, so after the fight, there is a helicopter that can only carry 2 people, and you have 5 injuries. So paramedic, and that is 1 trained person within the squad, have to do this medical triage and determine very fast who out of those 5 injured people has a better chance of surviving. So it is important to put the basic medical knowledge on the technology. And to implement basic medical knowledge in the sensor technology, and if possible, to provide data streaming from those sensors to the transport devices, and then from transport devices to the healthcare institutions that are working on the field. And those techniques can be then implemented in first, for any critical medical situations, for example, earthquakes, or even let's say car accidents, and then they can even be provided for home monitoring purposes. And this was this application that was published, and as you can see. Here, if you check the authors, you'll see that most of those authors are actually medical personnel. And I would like to point out this interesting person here, Franz Tasic. He's actually physician and specialist in chirurgy in Slovenia. But he has 2 faculties, and one faculty was the faculty of electrical engineering, and the second one was the faculty of medicine. And this is the type of knowledge that is very important for developing this type of systems. Why? Because, for example, if you transport the patient with an emergency car, on paper, you only need to put some sensors and collect data and transfers those data via any technology to the hospital. But in reality, you have so many noise. The emergency car is not traveling in the right direction. That means that the patient that you have put the sensors in a very hurry way is actually moving constantly, and then you have different noise of different medical device within the emergency car, and so on. So the problems are practically endless, and you just want to make a small increase in the quality of data, because you're very, very aware that though if you manage to do this, you can actually save more lives. So that is why it is important to go with networks. And this is just to illustrate this. I will not go into details. This is what type of technologies, what type of protocols, what type of communication you have to provide between what different stakeholders is put here into this slide. So I will be very happy to answer any of your questions later on. And then we said, okay, if we have problems of this sensor data collection in these not stable environments, how about using the same approach but in a very controlled environment, for example, at your home? And since we have very stable environment, can we manage not to use not wearable sensors, so to use a non-intrusive approach, to try to collect data without actually connecting any type of sensor to the actual patient? And this is our approach of collecting data with sensors that are not attached directly to your body, but you put under your bed or on your bed, and then or your ceiling, and that can detect simple movements while you sleep. Why? Because there is a medical knowledge that if you have apnea, and that is, let's say, that is problem with breathing when you're sleeping, then you can actually, don't have steady way of moving in your bed while you're sleeping. And we collect the data, and then we try to focus on how to create an environment that will take care about the privacy of your data. So if you have this typical ambient assisted living model scenario where you collect data and send it to the cloud, and then medical personnel analyze it, or a medical expert system analyze it, and then give back feedback to the users. It is very important to determine what is the best case scenario in which you send enough data for the expert system or for the machine learning systems to be able to determine some kind of goals or perform classification or create recommendation, but in the same time not to be able to recognize the specific end users for which they are using those algorithms. So we played with that. We try to determine what kind of sensors will produce data that we can use best. And it was the first results. This is very, very recent study. The first results were very interesting. And then when you discuss these results in the wider scientific community, you find out that you can relate, for example, sleep apnea with the early symptoms of COVID-19, because sleep apnea is a respiratory problem, and the severe cases of COVID-19 creates respiratory problems. So, for example, now we are talking about possibility to provide this kind of sensor equipment to the positive COVID-19 patients that are in isolation at home, receiving medical treatment, in order to have early warning which of them should be transferred to the hospital before it is too late. So this kind of networking creates and discussion creates very interesting possibilities. And once again, what kind of sensors, how they have to be fine-tuned in order to create useful information, how they have to be placed in what positions they're all things that to be considered. And then the final example of what you can do is this telemedicine robot. And this is the project that was not led by our group, but it was led by the people in Italy. But it is very, very interesting approach, and it has very nice commercialization spins. Originally, this was the robot that was aimed to to go in a non-human friendly environment situation and check for the medical conditions of some victims there. So basically you create this robot that you can move in different directions, and then when you find the person, you have this hand, and this hand is full with sensors. You try to put those sensors using that robot hand on your patient, and then you have the same story as before. You collect the information, you send it, and so on and so on. And then we find out that this kind of robot would actually be more useful for the people that live in isolation, for example, elderly person, because they can track the elderly person. The elderly person can communicate using the monitor on the robot with the next of kin or with a specialist that lives in different area of the town or that don't have time to go and visit them. And then, if needed, we can use these sensors from the robot hand in order to check the pressure, the blood pressure, or any specific whatever is implemented in that robot hand. And then, so since you have robots here, you have to take care about robot navigation. And once again, it is simple to create a robot that navigates in the controlled environment. But then if you have a robot that needs to be robust and sensitive enough to carry out to collect and carry out the information, and they have to navigate even through simple variation of carpets and floors and with many obstacles on the way, it is not as simple as it might sound on the first case. So these were all cases that you can implement if you have a good network and if you have a good local team, and if you think with different how to use different technologies in a good manner. But those technologies, as we mentioned, have their challenges. So how to share data, how to make this interoperable, how to make it explainable, how to make it private, and how to trust those data. And I've already mentioned most of those challenges. So I just want to say in short that now there is a technology that can existing that can actually address those challenges. And I will go very fastly because this is not from the work of my group, but I will just go fastly that for data sharing possibilities, there are different set of standards. And here on these slides, we have a standard that is provided by, well, quite a few big industry players, that is Open Health Information Exchange standards, and that is taking care about all these different data sources and different communication channels, and try to standardize the way they can collaborate. Then we have this open national contact point architecture, which is very important. Currently, we're having for the exchange of data between different states. So currently, the European Union is financing quite a few projects that actually try to establish not only the processes in which different national healthcare institutions will work, but also the actual practical implementation of that healthcare, at least administrative healthcare data exchange. If you live especially if you live near the border, this enables the medical tourism. This enables the treatment of tourists and so on and so on. And this is once again just a standard. And then a lot of work is done on explainable models, especially in medicine. And this is just one paper. It is not done from our group, but this is something that we do need to consider. If you remember, we try to to use this specific machine learning technique of collaborative filtering because we believed it is the best suit for this evidence-based medicine. And edge computing is, I've already mentioned that we try to determine what kind of processing can be put down to the sensors in order to protect the privacy. And the last thing that I would mention from my group is in the last 3 years, we're experimenting with the blockchain approach to take care about, to increase the trust into the healthcare systems. And I've already gave you the information of, for example, how we can deploy the blockchain layer into the COVID tracking application in order to increase trust of the citizens, because the citizen will be informed who is accessing his or her data and for what purposes. And as a conclusion, what you should take home from this lecture is you need interdisciplinary cooperation, and you need that type of education. And that type of education is not existing currently at least within the European Union. There's some curricula that are starting in Italy and in Norway, but I'm not sure whether they're enough, because we need more specialists in this field. And this technology deployment approach is never-ending cycle. You deploy technology, and then that technology present you a new challenge. For example, this blockchain technology is okay, but if there's this huge challenge that since they're putting all the transaction practically that are happening on the blockchain, and that transaction logs are available to all of the stakeholders. Maybe in 50 years from now, there will be technology that will be able to crack the current encryption used in those chains, and that means that in 50 years from now, everybody will know about all the medical records, all the contacts from your person. So you have to be aware that you go that way, then you have to take care about the possible privacy breaches that will happen in not in the near future, but in the future probably. And how do you tackle with that? Well, you have to be persistent. So you have to, there's new challenge, you try to find a new solution. And that is very similar to the Star Wars saga. And if you go this path, I just have one sentence to you: may the force be with you. So thank you for your time.
Okay, thank you. Thank you for very interesting presentation. And we have several questions from remote participants. And the first one is, you mentioned it, connected health algorithm. Is it based on explainable artificial intelligence? Do you have any patent on it? It looks that such device could be useful.
Well, connected health is actually a paradigm, and it's not just one paper or just one patent. Connected health is a paradigm that aims to provide a better healthcare paths to everyone using technology in every possible way. And regarding the patent, within my expanded universe, there are quite a few patents, and some of the patents are with open license because of the projects that finance the research that creates them.
Okay, next question. There were mentioned many very nice practical examples of equipment.
Yes.
Are they used in practice?
Yes. For example, this NATO project was actually deployed in the hospital in Celje in Slovenia, and it is, I think, still in usage there. then we have developed this SAVI, that is the name of this device, that is practically easy to transfer sensor set that you can use in a medical situation. It won the innovative prize in Slovenia because the project was done in cooperation with Slovenia. We were just the engineering part of the project. Regarding the robot, there was a company that actually create that type of robot with a modification that is offering now on the commercial market. The company is from Italy. Regarding this sport tracking application, the application Sportipal is not active now, but when it was active, it was a good commercial success. It was, we had the data for almost 500,000 people on daily basis, and that was in the time even before the sport tracking application were very, very popular. And yes, we had many users on that. Yeah.
Okay, thank you. Next question. What is the positive or negative approach of blockchains in your point of view in medicine?
Well, the purpose of blockchain is to provide trust. That is the first thing. So, but I think that in the medical domain, we are talking about blockchain-inspired technologies. So we're not talking about this Bitcoin-like types of blockchain. I think that the nodes will be federated, and the hash keys within the nodes will not be calculated in the same way using the same type of consensus algorithms as they are used, for example, in this financial or virtual money type of coins approach. Basically, you'll have 6-7 stakeholders plus one person, and they will create the ledger, and they will exchange the information. In that way, the transaction process will be very fast. But what is important, the trust will be enabled. Why? Because we'll have notification whenever someone from your ecosystem is accessing your data. The ecosystem in a typical scenario consists of a medical institution, healthcare insurance institution, maybe healthcare authority, for example, in the case of a COVID tracking application, and yourself. So whenever someone from that ecosystem is approaching your data, every stakeholders get notification, including yourself. That practically means you have information that the Ministry of Health has access to your data. And that is, I think, important, for example, for a cultural application, because you have these glances of information that might have a great deal of meaning for you.
Okay, thank you. And the last question, could you please comment about usability of other standards for health information exchange like HL7, ENV 13606, DICOM, SNOMED, and others?
Yeah, well, in our group, we had this project for inter and intra-border cooperation, and we are massively using HL7 standard for medical record creation. Even in this, we have this experiments with the blockchain exchange between health care providers and health insurance providers, and also they're using the HL7 standard for exchange of the data. I know that there is this huge project within the European Union that talks about health information standards, and different standards at the time being are more suitable for different specific type of healthcare data exchange. Unfortunately, I'm not an expert in that. If you work within the universum, then you have different expertise available in the universe and within your own universe, and you're simply asking for their opinion and their standards. I only know that within our group, we are mostly using HL7, maybe because it is most easy, or maybe because it is most well documented. I'm not very sure about that.
Okay, thank you very much. So thank you for interesting presentation. Thank you for interesting discussion. But it's a pity that we are short in time and we should go to our session, next session. And thank you, Professor. And could you please join to a Zoom channel, which information I was provided to you a few days ago, for short interview in order to answer for several questions for our public relations department, okay?
Oh, it will be my pleasure. So just can you send me some link somewhere? Am I having that Zoom link already?
I have provided it by email yesterday.
By email, okay. I will look it and I will join you in 1 minute.
Okay, and our staff member will wait you in this channel. So thank you very much, and I hope to see you next year, Kaunas, on site. Thank you. Bye.
Hope so. Bye.
Bye. Okay, and now we should continue our conference, and let me introduce the chair of a special session on language technologies, Professor Jurgita Kapočiūtė-Dzikienė. Oh, sorry, okay, sorry, it's my mistake, okay. And now we'll have a coffee break for half an hour, and we will meet there after 30 minutes. Okay, thank you.
language technology session. We shrank this year a little bit, but I hope the next year everything will be back to normal. And what is not normal, that we still do not have remote presenters, but at least we have one presenter here. So I think we will start from Sanait, from you, please. And and her topic is deep learning-based part-of-speech tagging of the Ethiopic language. Okay, so please.
So hello everyone, my name is Sanait Garengatis, and I'm here to present about our paper deep learning based part-of-speech tagging of the Tigrinya language. Part-of-speech tagging is not a new concept in the area of natural language processing. It is a core concept that many higher applications of NLP rely on, and Tigrinya is a morphological rich language with a low resource in the electronic format of annotated and annotated corpus. And previously, part-of-speech tagging for Tigrinya is solved with the traditional machine learning approach. The main goal of this project is to solve the part-of-speech tagging task with the most innovative deep learning approach. And to maintain this goal, the following tasks are performed. We do some research analysis related, and data preparation, experimenting with different deep learning approaches for classifiers and vectorization type, and seeking for the best model where manually and automatically tuned the hyperparameters, and at the end we follow some recommendation. Tigrinya is from the Afro-Asiatic family that belongs to Semitic languages along with Hebrew, Amharic, Maltese, and Tigray. It's characterized by rich derivational and it's implemented for gender, number, and case. GES script is adapted to write the most Semitic languages, particularly Amharic and Tigrinya. The data or the corpora we used for this project is the Nagaka Tigrinya corpus version 1. That's the only freely accessible corpus with the part-of-speech tagged words that's collected from the Eritrean National Newspaper, and it's released in 2016. It consists around 72,000 tokens, 4,656 sentences, and it's labeled to 20 different part-of-speech tags. As you can see in this picture, the corpus is prepared in the Latin and GES script, and for this project we used the Latin. And in the right side, you can see the distribution of the part-of-speech tagging throughout the corpus. The vectorization is always the deep neural networks is applied on the top of vectorized words in order to perform the statistical and mathematical calculations that words are represented in the real value vector. Thus, the similar words are projected and closer in the vector space. Therefore, we use a word-to-vector approach in this experiment with the window size 3 and with 100 dimensions. We saved this pre-trained word embeddings for later experiments with the DNA classifiers. So, in the experimental setup, we outline some metrics. That's the evaluation, baselines, and significance measurement. As you can see on this, the evaluation metrics, we used accuracy and loss. And the baselines, we calculated the random and majority baselines. And in order to the classification to be appropriate and reasonable, the accuracy should be much above the random and majority baselines. Therefore, we were expecting our results to be higher than 27%. And the MCNMR test with the significance level 95% is calculated to see if the best and the second achieved results are significant. And we use the Python programming language, TensorFlow, Keras, and Hyperes. Within the DNN deep learning, we investigated this kind of methods, the feed-forward neural network, convolutional neural network, long short-term memory by LSTM. and we tuned the hyperparameters of activation function, epoch, and patch size. And the tuning of the hyperparameters, we used the manual and automatic techniques. We split the data sets, which is 80% for training, and which 20% for validation, and the rest 20% for testing. So the first one is the feed-forward neural network. We tuned the hyperparameters manually, and we used the one-hot encoding vectorization. And we tested the hidden layers, 1, 2, and 3 hidden layers of neuron 256, 512, and 1024 with epoch 100 and patch size 256. You can see in the architecture of the model and the picture. And the results is we achieved the 28% of accuracy, that's the highest, with the softmax activation function. But different hidden layers and neurons didn't show any significant difference in the accuracy. And the second architecture or the model we tested is the long short-term memory. We tuned the hyperparameters manually, and we used the vectorization that pre-trained neural word embeddings, and with the same epoch 100 and patch size 32. The highest accuracy achieved using this model is 89% at the softmax activation function. The third one is the bidirectional LSTM. The same, it's tuned manually, and we used the neural word embeddings vectorized vectors with the hyperparameters of epoch 100 and patch size 32. And using this model, the best accuracy is achieved at the softmax activation function, which is 91%. And the convolutional neural network is also tested for this task. We tuned the hyperparameter manually, and vectorization is the neural word embeddings with 1 dimension, kernel size 3, and 100 filters. And the highest result achieved using this model is 15%. It's low with the ROLO activation function. So manually hyperparameter tuning is computationally expensive and it's time consuming. Therefore, we also try to optimize the accuracy by tuning the hyperparameters automatically. And we tested on 3 methods on the long short-term memory, bidirectional LSTM, and CNN. We tested the parameters, activation, optimizers, patch size, neurons, and the layers. We used the TPE such strategy, and we did this in 20 iterations. As you can see in this table, the highest accuracy achieved is using the BioSTM model and activation function sigmoid. Still, it is the same with the manual tuned hyperparameters. Therefore, to generalize our paper, the previous work for the tigrinya part of speech tagging is using the traditional machine learning approach, the conditional random fields and suppressed vector machine. They achieved the highest 90% accuracy by enriching the contextual features and morphological and affix features, but our BioSTM DNN model outperformed this previous work for tigrinya language. Results for the DNN methods are much higher than the random and majority baseline, so we can say our classification is appropriate and reasonable. Tuning hyperparameters automatically, it gets its highest accuracy at the BioSTM model, but yet it didn't beat the achievement of manually tuned hyperparameters in the BioSTM, the same model. But in the convolutional neural networks, it shows a good improvement that the accuracy increases from 15% to 61%. Feed-forward neural networks perform poorly, and we are saying that it's not suitable for solving this task. Working with the small amount of data that we get from the Nagaka tigrinya corpus, it requires the help of the rule-based methods, such as some linguistical features. It needs more feature extraction for the better accuracy using these methods. The MCNMR test shows that the difference between the best and the second achieved results are statistically significant. To conclude my presentation and about the feature works, The best accuracy we achieved in this experiment is 91% using the bidirectional long short-term memory and neural word embeddings. And the contribution of this research is it's the first time to test the state-of-art innovative methods of deep learning for the Tigrinya language, and it's also for the neural word embeddings have been trained for the first time and use it for this part of speech tagging task. The recommendation about the classifier and the vectorization should also benefit for the other Semitic language that shares the same features with Tigrinya, such as Tigray, Saho, and Afar. And our future work will be to find more diverse data and further natural language processing applications that can initiate it without part of speech tagger can be performed, like the dependency parser. That's all my presentation. Thank you for listening to me. If you have any question here.
So thank you very much. And this work is very clear to me because Sanait is my former master student. So, but let me see if there are some questions from remote participants. Yes, this is the recent question. So do you have planned the results of this research to put into the practice? For example, develop and implement kind of software, tool or other?
So as I said in the first presentation, in the first slides, the part of speech tagging is the core concept that many higher applications of the natural language processing rely on. So our future works is depending on these findings, we want to continue onto the other practical research like machine translation, dependency parser, any sentiment analysis, other practical NLP applications.
Okay, thank you very much. I think we don't have more questions from remote participants, but do we have questions here? Yes, please, but please come here and use the microphone.
As I think it is okay. As I understand, your plans is to extend the corpus of your language, your investigated, and rule-based methods are not in your future plans. No?
No, if I get like some, I don't have much information about the linguistics of my. So if I get some paper from the linguistics department, we can enrich like this using the linguistical features.
Okay, thank you. Do we still have questions? Do we? Yes, please. Please come and ask the question. You need to use this microphone.
I saw you were tuning the parameters, and what did you use? TPE suggest? Is it a Python?
Yeah, it's the hyper-expectation.
Oh, okay.
Okay, thank you. More questions? If no, thanks the speaker. Thank you very much. And let me see if there are more people. Am I correct that that's it? So what you could suggest me to do right now? Do we need to wait or just close the session and that's it?
of images. And image simulation, this was a keynote presentation a week ago in another conference, which is more based to the biology and the sea and marine sciences. So basically I start with some simple techniques that as you can see in the top row, there are underwater images from the coral reefs, and you can see this coral is already dead, but now it's getting occupied by some algae. And to measure the extent of this, they use the thresholding technique of grayscale images, so to measure the extent of this occupation, and in the bottom line you can see they measure how many circles of what size can be fit into that, and this kind of measures this structure. Not only percentage of the whiteness which is occupied. And the simple trick can be done with using the grayscale image and choosing a threshold. So you choose a threshold between 1 and 256. This is the number of colors in this palette. And then when you choose optimal threshold, then you get this binarized image, which is a very simple way of doing segmentation. And if you are lucky, and if your task is simple, then you get object extracted. And there are many heuristics which can help you to choose this threshold automatically, not by hand. I personally like this triangle heuristic, which finds the top peak and makes a triangle with the longest 90% of angle here. Okay, so this is the angle of 90%, and this line here should be as long as possible. And when you find this line, you just cut it there. So you adjust this triangle side so that you find the highest perpendicular line, and this gives this recommendation for a threshold. And there are many others. For example, also is based on the means. It finds the highest distance between class means, and in between it puts the threshold. So you can test all these heuristics and many more and adjust them by hand as well, manually, with some open source tool, which is called Fiji. It's image G evolved into biology analysis, biological images, and especially microscopic images. So you can choose by hand, or you can choose by this heuristic. You can use this heuristic as well. And here is a real-world example, which I took from a page where they show the good algae, which creates it creates oxygen. So this is a good, not harmful, but still it blooms sometimes. And when you have big blooms, they want to measure them from satellites. But here we have a microscopic image of this algae, and you can try to segment. So first you make it grayscale, and then you choose a threshold. For example, I here have chosen the Otsu threshold, which automatically finds a threshold of 162, and you have a binarized image. So very simple trick. You can change the colors, invert the colors, or even make it red, object red, with a background shown. So this useful tool has another menu where it does the same thing, only more automatically, with all possible thresholds. So it's called auto thresholds, and let's try all. So here is the result, and now we can say that much of the heuristics for this type of the data, if we have lots of these images, work perfectly, maybe with exception for percentile heuristic and also, yeah, and Shanback. So two of them are not very good, but others are pretty okay to choose for segmentation. And you can also invert this picture if you wish. Okay, so this was a most simple way of segmenting by using grayscale image and thresholding. Another way is called active contours, and it's related to snakes and to balloons. So snakes work like when you put a circle around your image and let him evolve using physical formulas based on color and the texture. So what happens, this thing moves until it is blocked by some edge. So here is the edge, and we try to get it. So sometimes we catch this middle circle, sometimes not, depending on the technique and initialization. You can sometimes initialize 2 lines to evolve together. And this is a nice trick, which works sometimes better than thresholding, because it's more adaptive. And here we try to use it on microscopic images of Prorocentrum cordatum cells, which causes the blooming in the sea. And we try to get their contours to measure automatically. So what we did, we proposed to use a particular centered on the cell edge filter, and this edge filter is directed to the cell center. And then by using this filter, we kind of make it brighter, the cell which we want to process. And then we put these snakes on, and these snakes stop right on the good border, on the good edge. And when we tried the classical thing without this filtering, we got pretty messy results by using those snakes without this filter. Okay, so playing with processing of images now, we can see helps even when using classical techniques. And here another help was very funny for us because we worked with these cells for several years. And then once they showed us the microscopic photos from fluorescence, when they turn off the light and turn ultraviolet on. So what we got fluorescence microscopy, and we said you should have shown this in the first place because it's very good to catch the objects there. No noise, no bubbles, no other garbage in the usual light microscopy can be seen around, lots of edges, etc. So we're very happy to find that they are floating in the dark. So we use these double pictures then to find the centers and then to extract the contours using these adaptive snakes. And then another trick we tried with those adaptive snakes, with these active contours, is that it's pretty sensitive to initialization. By some parameters, you can get very nice contours, maybe closer to the center, maybe outer, but sometimes you get pretty messy result then. So what we said, okay, instead of showing the contour by hand, as you can do for some techniques below, this was machine learning based when you show the contour and train a model. What if we just rank them? What if we create a machine learning model not for finding contour, but giving a grade to it? And we easily generated hundreds of those things automatically by changing 2 parameters of this active contour method. And we found many potential contours which we graded later. And when after grading, we used this result on unseen images by generating lots of contours again, and then using this model to write a grade. And this was pretty good result to correct the active contours and also outperforms machine learning-based idea. And machine learning-based idea in the old times, before this deep learning, was looking like this. This is the, from 2017, but still it's a bit older technique. When you take an image and transform to many different pictures, you just try to find edges in a different ways, you do Gaussian filtering, blurring, etc., and you stack them up, and you take 1 pixel through all these transforms and say, this is our feature vector. So very simple trick, you just stack all those transformations, take the pixel, the same location throughout them, and put them as a feature vector, which indicates the number from 1 to 256 if it was grayscale images. And then you have the class label. So pixel-wise segmentation, when you say this pixel is one class, another pixel is another, and you train the model, and it works like we can see on the right. It finds cell borders and 3 classes. So it works by choosing this set of features. So this is the transforms we can choose. There are many various transformations of images. And you can use this fidget tool, which I talked about before. It has some plugin, which uses Vecca underneath. And the models created can be random forest, for example, one of the most popular. So good way to play around with machine learning-based segmentation, but a lot of work to annotate the images, to prepare for the model. Here our PhD student, Rimavicius, tried to do it a bit smarter, not pixel by pixel, but using superpixel regions. So he went from this image to homogeneous regions, which can be get by using slick algorithm. It calculates so-called superpixels. And these are good for annotation, but also can be used for making tasks more simple. And instead of classifying pixels, you can try to classify whole region. And using two-step technique, which he proposed, we get these accuracies for 5 classes. As you can see, then there's pixel accuracy and also region accuracy. And these are above 80%. And we used a random forest and SVM here. Okay, so here we stop, and now we have a revolution of neural networks which come back with new techniques and new resources. And basically, this network started in 2012 with AlexNet, and then evolved. And the idea, I think most of you have seen, this is the layers, and in each layer we have so-called feature maps, and these feature maps get by filtering the image by using trainable filter. This small filter here is moving through the image and it's trained on. So when you use this training of these trainable filters, you get some hierarchy of features which visually look semantically meaningful. In the lowest layers, you have some lines, edges, some small, very small parts, very geometric related features. And in upper layers, you start appearing noses, eyes forming, and even in upper layer, you get some generalized faces. So it works through those layers. And tasks which are solved by similar architectures can be split into these 4. I mostly concentrate on semantic segmentation, but there are more interesting things like instance segmentation, for example, where you calculate separate objects, similarly like here in object detection. In object detection, the rectangle is enough and a tag. In instance segmentation, you already cut it out perfectly with the shape. So yeah, so upper tasks are more easier, lower tasks a bit more hard for these models. And here is the evolution of these models. Lots of them appeared, lots of different architectures proposed, and here we see SegNet, maybe more here. UNet is as well, old one. And let's show you how the UNet looks. It's one of the first those simple models. It works by autoencoder idea, where you have input image, and here you have the output segmentation mask you want to get. But in between, you compress this image through convolutions and through downsampling. You get some bottleneck here, which is internal representation, and from this internal representation, it tries to build up the segmentation mask. So basically, you compress the image, and from this compressed one, you go up to segmentation mask. So it tries to learn this mapping. And here is results for C-related images. I couldn't find many. There are some libraries of images you can train upon. This is one of the largest libraries with 150 classes. And it's a semantic segmentation task. It's important to note, not like ImageNet, which tries to classify images. Here we have semantic segmentation, very pixel by pixel annotations, very detailed ones. Yeah, and you can play with these kind of data sets to study these architectures. And here is some comparison, example comparison of those architectures which appeared in last year's PCPNet. I would say one of the architectures I like personally. You can use ResNet as a backbone. And the accuracy, as you can see, this mean intersection over union, it's a semantic segmentation accuracy measure, is in the range from 30%, got up to 45%, and it's going up even more. And you can see it, but after PCPNet, this going up was more flat, I would say. It didn't outperform the new edges that much. And you can look at this nice site, I think you know. You can look around those competitions on different data sets, different architectures, and papers have even the code. It's very nice to explore. Yes, and here I have some architectures which were used for underground data. So Deep Lab from Google was used to segment underground images, underwater images, and here they have 16 classes. It was compared with PCPNet, and they found that Deep Lab is, for them, it was better by a few percentage points. And they created this data set you can download, because data sets are a golden thing in this field to play around. So this is one of the nice data sets for underwater segmentation. Here is the results, original picture, and the last one is expert annotated, so ground truth segmentations. And then in between you have those models trying to segment that automatically. So DeepNet was found better for this data set here. Another one, collection of 1,600 images was also annotated with 8 classes, underwater images, and were very new data set you can play around. And they used SwimNet, a specific architecture which they created for this, and show that it's even better than DeepLab or SegNet or UNet. And here are their results. So here they tried to find these objects underwater, like, what was the classes? O was robots, yes, so we can see the red color is the robot mask. Here is another paper which was used for underwater images, and they tried to measure the grass, which is growing, the grass fields on the seafloor. And by measuring these grass fields, you can know how much nutritious this place is, how it's good for biological diversity. So you can see this difference between ground truth and the model. So blue ones are false negatives, and green ones are false positives. So these are the difference between those, or the errors that models made for finding the underwater grass fields. Here they try to hunt fishes with object detection and segmentation model. Not bad precision and recall. Here they try to hunt jellyfishes as well. And they use ResNet version 2 model. And Detectron library was used as well for similar tasks, but it was used for its water, top of the water, not the floor. They try to find these classes like copepods, bubbles, oily gas, some plankton detection. Okay, and there was a nice proposal here with synthetic images. You can use, like in self-driving cars, you can use games. Guitar, for example, this Grand Theft Auto. They are very realistic now. So basically, by using this idea, you can simulate and create annotations automatically without the need for human annotating images. So by using these synthetic ones. And here was an interesting article. They used synthetic generated underwater places. So they could use later they make a model of a real thing underwater in 3D. And they play around from different angles and different lightnings and create lots of data for model and use them in real underwater situation later. So there was some accuracies which they got around 87%. To segment object and background underwater, like for working under ships, under wrecks, at those conditions. Oh, here are main tasks, and 1 minute left, okay. There are tools you can use for label data. So label me, label image, uses boxes only, VGG image annotator to prepare these images. You can use very nice one. Annotation app, pretty flexible, you can configure. It allows many shapes to use for preparing this data. And this is from Intel, very serious tool they use inside to prepare semantic segmentation data sets for self-driving cars. But it's pretty professional, this one. And there are some online ones, like when you can use a page and log in and do it in a project in a team way. So we use, for example, label box to label our own underwater images. And here is the team activity. We see that in spring we were very active annotating, and then it was some activity in summer. Yeah, And here are some objects which they annotated, thousands of objects annotated, and here is a percentage of all objects. So most were of yours. Of yours is like a C-star object. Now, in the end, when they have a team of annotators, some annotations start to overlap because they annotate the same thing. So what we do, then we do a survey to choose between annotation which looks the best. So several experts annotate, and then we give them this survey to choose. They don't know which one is which, but they choose which looks nicest. So they try to create a ground truth which is expertly selected. And in underwater, we need to stitch images to get the maps of 2D for this kind of analysis. This is the stitching process. This is a stitching process from some tools which you can use, commercial tools. This is one based on MATLAB, and this was a technique from 2012, which Klaipėda scientists use this technique. And also you can do even 3D reconstruction from those video images from underwater. I've tried, it works. It creates something like that with a texture put on it. So not only on the ground they're doing this, they're starting to do this underwater, these 3D reconstructions. And you can use some software for this type of task as well. And the main task for underwater images is the color effect, which water affects the colors. The deeper you go, the less color you see. Especially disappears the red ones, and the blue and green ones appear in the histograms. So there are some tools they try to eliminate this effect, and this is a specific task. For example, last one, you can see the fish very brightly now after removing the effect. And there are many new articles in this field as well. So that's basically it. You can use Fiji for simple segmentation tasks. You can machine learning, try to play with machine learning and annotate and train the model with Fiji as well. But then you can move on to new revolutionary architectures which need lots of data. And for this data, you use some tools to annotate it. And also you can use some specific tools for creating these maps or 3D scapes from video data and images. That's it. Thank you for the attention.
Do we have any questions?
Do we have remote participants?
We do not have.
Oh, great. I like this.
From remote participants, so very thank you for this, let's say,
Spontaneous.
keynote special presentation for Professor Evaldas Vaičiukynas. Thank you very much. And now, according our schedule, we should have lunch, and I hope to see you and to meet you virtually after the lunch at 1 p.m. And we will have a special session on smart e-learning technologies and applications. So, thank you very much, and see you after 1 hour. Thank you. Okay, let's continue our conference. So now we'll start the special session on smart e-learning technologies and applications. And we have two presentations who presenters missed their time slot in previous section. So we will try to find the time slot for them in this section. So let me introduce the chair of this section, Professor Danguolė Rutkauskienė. So the screen is yours.
Thank you, Audrius. Welcome to our session number 6. It's the last session in our conference. And really, I am so happy to see you here in the room because of a lot of differences was because of the virus. But as I know, we will have a lot of remote participants, and of course, some of some of us, we can see record of our presentation. As Professor Audrius mentioned, we have 6 presentations during 2 hours plus 2. And I would like kindly ask our presenters to be exactly 15 minutes, not longer, because each of you have 15 minutes for your presentation. And in our first version of our ideas, it was 15 minutes for presentation and 5 minutes for discussions. And maybe we will minimize a little bit our discussions. And now I would like to invite our first speakers, 2 of them, Tomas Blažauskas and Lukas Paulauskas. Could you introduce yourself, title of your presentation, and of course, research idea, please.
Let us prepare. So, hello everyone, hello dear participants. Today myself and Lucas, we will present our creation, Escape Lab, Chemical Experiments in Virtual Reality. So let's start. Here you see the structure of our presentation. We will talk a lot about the project, about the ideas, discussion, experiment. But first, let's meet my good friend Anna. Anna wants to share some of her thoughts.
Dear conference participants, my name's Anna. I want to show you some of our laboratories nowadays. Look around. Do you see the difference? Right. There are no students these days. And these nice laboratories cannot teach anyone. Teachers provide lectures online, but it is not the same as working here. Students are not gaining the necessary skills. This situation is especially bad for kinesthetic learners, who are learning by doing. So, is there any solution? How could we help our students?
Okay, thanks, Anna. Well, the solution there is. Therefore, we are here to present that solution. But before going into the specific solution, let's see some mystery. Okay, you saw a video. Basically, it's the game that you can find on Steam. And there are several things about that video. First, it's about the gamification. And the second, here you see the escape rooms. Such rooms are already appearing in the universities, and KTU is also participating in one of the escape the room project. Although we are not participating in that project. And the idea is to provide these real laboratories. So our proposal is to create the sandbox model for the laboratory. Basically, it means that you can freely interact with laboratory objects as you can do it in the real world, and split that sandbox model into parts so we can use, so we can provide some teaching. And that laboratory model, it has separate parts. It has various physics and interactions to implement it. For example, one of the most important things, there is a liquid system, because, you know, chemistry, and there are a lot of various liquids. So what's implemented here, we can fill in some bottles, we can spill out, and we can mix the liquids. Besides the liquids, we have several other interactions. For example, fire. Would you like to burn everything in the lab? If you would like to, so you can do safely. What's useful also, having the possibility to draw. And to do it not by clicking the buttons, but by using your own hand, using your interactions, by actually grabbing the pen and drawing virtually. You saw some breaking. You can break a lot of stuff in the laboratory. And here you see some examples of the interactions. And as you can see in the video, the persons can actually bend their fingers in real reality, and the same thing happens in virtual one. You can switch on the lights, and you can grab a lot of other objects. So we have created such a program, and we wanted to show it. And now about the experiment, we'll talk Lucas.
Okay, so hello, I will present the experiment that we did with this Escape the Lab project. So what we did was presented during one of the events that was Game On. And basically the setup of the project was during the event we isolated a 3x3 area, let's say a play area for people to try out the program. And during during the event, anyone could have participated. Anyone eligible to use virtual reality was able to participate use this experience. And basically what we did, we recorded every session with non-personal data. So basically what we had is data of how people how people played the game. So for starters, we recorded how much time every person took to complete levels, what they did, what objects they, with what objects they interacted. And from the data that we observed, we saw that when our program was basically separated in 3 levels, most of the participants finished the first level, which was basically an explanation of how to use the virtual reality mechanics. And the other level, the level 2 and 3 completions were a little bit smaller because these were the levels that actually required people to have some knowledge about chemistry and, basically try to do some experiments. And we can see that the level 2 and 3 was as I said, completed less because, people probably didn't have enough knowledge, or maybe the project itself did not bring enough educational, didn't educate them enough to how to complete those levels. So basically, they didn't do the tasks or the objectives that were presented to them. To conclude, from the data that we got from the experiment is that this project needs additional work, maybe to add additional, some sort of educational explanation or something that people would be able to, conduct experiments in the virtual world, to, maybe help them understand how those mechanics work more and so on, so that the completion of those levels that there are experiments that needs to be done would be completed and so on. So.
Okay, let's go now towards the discussion. So there are many things to talk about. It's quite easy to set up and run, and all you need basically is such a device worth €400. There are lots of ways, and teachers can think for themselves how to teach, how to use the gamification. There are many interesting concepts, like how we...
There are many challenges, and one of them is to find a way to apply the method for learning theory. To modify a real laboratory to enable experiments with theoretical concepts. For example, We have invented the futuristic machine that allows us to combine molecules to receive chemical elements, and the scanner that recognizes these elements and provides descriptions.
Also, very important thing is to relate all the theoretical stuff with practice.
Another concept that we have been working on relies on showing us how our every action affects the environment. What is the relation between the things we learn and the real world? We have developed a system for changing the surrounding world depending on the task the student has completed.
And the last thing we wanted to talk about is the support. So basically we need to supervise the learning. So we created a system for broadcasting the sessions, either doing it in real time or watching the videos. So we will show just the example on how it works, if we will be successful. Kas? Okay, now I will enter into virtual reality. And now I will just walk inside this laboratory, and actually you could see that the browser is showing what I'm doing in such a way I can see the things I need to see and also interact like we show you in the video. And this require only a browser. So to conclude, let us escape the labs. Let us escape Adobe Connects, Zooms, Teams, and finally, let us escape PowerPoint. Thank you.
Thank you. Fantastic presentation. Of course, I think all of us, we want to participate in virtual way, but maybe next time, sorry, because of the time, and maybe during coffee break. And some questions, because we have 2 ways for the question. If you want to ask, please come close to us. It will be a very nice picture with you. Second, if you are in a remote place, you can ask using Zoom, and Volker, he will help us. Could you stop your sharing, first of all? Thank you. And questions? Okay. And what about questions from remote participants? Maybe in chat, maybe they can ask. No questions. Okay. Thank you. 1 minute, 1 minute. Important thing for the youngest. And for you, Thomas, next time.
Thank you.
It will be in gold, because we didn't print in gold. Okay, thank you.
Okay, thank you.
Okay. Yeah, virtual reality are coming and coming more closely to our everyday life. Oh, I was so happy about that. Now I'm very disappointed. I understood that it was as a gift for me. And now I would like to invite our next speaker from Germany, Klaus Norf, and he will present evaluation and design of higher education curriculum, and maybe much more widely presentation. And Klaus, no, Dinah, because our colleagues Diana, she informed me that Klaus, maybe again because of the timelines, but this is in Germany, not in Japan. No, it's much better in America. Okay. No. Okay, we have time, and now we can continue our presentation. And Pavel Bochev, gamification evaluation in game-based learning. Pavel, floor is yours.
Yes, I'm here.
Yeah, fantastic.
I'm here.
Okay.
Yeah.
We can see you.
Just to share my screen.
Fantastic.
It should appear shortly.
And Pavel, I would like to only to remind you, you have 15 minutes.
I will try to be shorter,
Okay.
so I will speak.
Thank you.
I will speak faster without video because I will show animations later in my presentation. My name is Pavel Bochev, and I will present gamified evaluation in game-based learning. Actually, this presentation is continuation of my previous presentation in the previous ICIST conference. It was in Vilnius. It's a very short introduction about gamification. This is the set of processes and activities which introduce game-specific elements into a context which is not a gaming context. And if you look at Google Trends, this term gamification applied into education, it like exploded 10 years ago. Before this, it was like minimal use of this term. So in education, there are two different perspectives. The first one is in scholar education, like in schools and universities. And the other gamification is for business education. They appear like two different branches of gamification. But unfortunately, in both branches, the main focus is on learning or acquiring new skills. So our goal was to change this and to focus not only on learning, but also on evaluation and eventually on assessment. So what I will present is our final result on gamification on evaluation, which additionally is suitable for students for self-learning and self-evaluation, which is also important to us. The beginning was with a virtual environment called Mero. It was platform-independent gaming environment. I introduced it last year. It is like a three-dimensional maze with several layers populated with virtual models. It is used in a course called Fundamentals of Computer Graphics. It is for computer science students at my university. During the lectures, I used Mero to demonstrate different concepts. And at home, students can use the same models to explore this concept and to try different ideas about them. This is just a snapshot of Mero. The top left part here is the empty maze. It's like there are stairs you can go upwards. The topology is flexible. And the left down is one model put inside this maze. Actually, we have made about 300 different models. You can see a thumbnail gallery of these models. Each of them represents a different concept from computer graphics. This was our first activity, but when we want to extend this to cover evaluation, it appears that these models, they're not enough. They're suitable for learning, but they're not tuned for evaluation of students. So we have to add new models which provide a kind of grading for student activities. And this model should also help self-learning and self-evaluation. The challenges are that in the domain of computer graphics, there are 17 competencies. They range from mathematics and physics to programming and art. So we had to capture all these competencies and create a student profile. And the second challenge is, because this is a game, students will generate a lot of data, a lot of scores, and it is not like a test. You have one student, one score. It is like one student has hundreds of scores. They are coming in real time. And each score is not a number. It's a vector of these 17 competencies. And our solution was to add several new modules to Mero and to connect it to Moodle. Moodle is the learning management system that is used in my university. We also developed a new metric called temporal average, which is able to process this scoring data, which is in real-time streaming. And we were able to create a model which provides three different aspects. The first is the competence profile of the student. And additionally, what is inside provides the evaluation, and what is outside provides information for future assessment. And as a second goal was not only to make students learn what is included in this subject about fundamentals of computer graphics, but also to develop soft skills which are usually left outside the main learning. For example, finding patterns of dynamic or static properties, or creating a sense of three-dimensional space and training spatial memory, and a lot of things like combining visual and non-visual senses. These things are not officially taught in the course, but by playing the game, students develop this type of soft skills. And we made preliminary tests with about 180 students between December last year and January this year. They played these models 19,000 times with a combined 380 hours. We have log files of what they did and how they played the model. So we have a very huge database with 1 million clicks and taps. We are still analyzing this. Additionally, we ask students to provide their observation in free form. So they have provided us a lot of data with what they think about the models, how they can be improved, or are there any technical issues. So we are still thinking that this was very positive result from our test. And I will go shortly about demonstration, because these are, I try to make them in real time, but there were problems with quick transfer of real-time data. So I make this a few videos. These are the additional models used for evaluation. They're also used for learning, but they're used also for evaluation. The last model, this one, provides information about the current score of the student. And this model is also a model which is inside the maze. So students, it's not like a normal test. They test and they afterwards see the result. They can play, they can see the result inside the game. They can continue to play. I have selected a few of these models to show short videos. They're like half a minute for each selection. The first one is about colors. They have to combine different color ink liquids to generate a specific color. Here is a short video. Another model is for matching motion and other properties. There are several balls which are bouncing, and the students have to find which ball is different. It could be the size, it could be the frequency, it could be the amplitude, it could be the material of the ball. So they have to experiment to see which ball is different. In this particular case, it is an easy problem because the ball which is different is slightly bigger than the others. Here is, again, a short animation. This freezing of the ball is necessary because sometimes it's difficult to observe many objects moving at the same time, so you can stop them and compare only two of them, then stop them, start another two objects. The third model which I will show is related to topological property called Euler number. It depends on the topology of the object, how many holes are there, how they are connected or touching each other. So the issue here is for the students to see this object. It is like a grill rotating, and to try to find this topological number. Actually, it can be counted or it can be calculated. It's up for the students to define which way they will go. the bottom one, this meter is, they select the value. It is an integer number. And one of my favorite modules, it's about matrix transformations, because in computer graphics, most of the transformations could be implemented with matrices. In this case, there are transformations visualized like boxes which modify according to this, and there are matrices below them. So student has to spin this carousel to match each transformation to the corresponding matrix. You will see spinning in a second. The last model which I will show is about a topic called surface subdivision. It is a way to make a surface smoother by introducing new elements in the surface. In this case, the goal is for students to estimate where is the position of a point which will make the surface smooth. This area should be somewhere in this red segment. I will start the animation. I will not show the other models, but all of them are configurable with several levels of difficulties. They're generated at runtime. I mean, this object is not the same. If you start the program again, it will be another object. In this case, the students will experience different situations within the same problem. Our future work is actually strange because the first one, which is short-term, is not a plan, it is activity currently. It is to embed these models in the course, these new models, and to use them as a component for grading students. And because the course started 2 weeks ago, in the beginning of October, it is already happening. And our long-term plan is to provide a better gaming experience by analyzing all the feedback from the students. And of course, adding virtual and augmented reality so that they will not use a mouse to control the things, they will use their hands or their motion to control these models. And this work is partly supported by 2 different projects. One is a national project, and the other one is institutional project. And of course, most of the work was done beyond these 2 projects. So thank you. I tried to be very quick. So maybe I can turn the video now. Let me see, because I will not show any more animations. I'm ready for questions, but maybe if there is no time, you can leave the questions for later.
Thank you, Pavel. Can you stop sharing, maybe?
Okay, yes, of course.
Because we want to see very big video on our screen. Pavel, some questions, because we have enough time for questions, and really I see some connection between your activities and what doing our Tomas Blažauskas laboratory, and I think maybe you will find some common activities in the future, especially when you speak about the project. Because as I understood, I don't know in which direction I have to look, because I want to see you, and of course I want to see auditorium. Yeah, some questions, please. You know, I have some idea, but really the future of educational sector are in our hands. Do you agree? Yeah, we became more and more important. Thank you, Pavel. Sorry, maybe really we try to save some time because we have, as you know, 2 additional presentations from previous sections because everybody liked our session. It's more important.
It's okay, no problem.
Fantastic session to be here. Thank you, Pavel. And now I would like to invite our next speaker from Timisoara University, Bogdan. Oh, fantastic.
Hello, everyone.
Fantastic, because as I know, you are celebrating 100 years anniversary in this year, yes? Fantastic, because a lot of participants in this conference came from your university, and greetings to Radu Vasiu, Diana Andoni. It means really, it's fantastic to have close collaboration among some colleagues in different universities. Floor is yours. You have 15 minutes, and later on it will be some questions. Please.
Hello, everyone. My name is Bogdan Dragulescu. I'm one of the authors of the article I'm here to present, entitled Hyperparameter Tuning Using Automated Methods to Improve Models for Predicting Student Success. The outline of the presentation is as follows. I'm going to start with a short introduction. I'm going to go over the objective of this study, the approach we used, the old experiment versus the new one that employs auto-melee techniques. I'm going to go over the result, discussions, and conclusions. So for starters, in the past decade, a lot of information is collected in the educational system by employing such technologies, and a large accumulation of data is currently built. So the next obvious step was to try to mine that data in order to produce some scenarios in which we can improve the educational system. This field emerged entitled educational data mining, which does exactly that. And some scenarios in that, the first popular scenarios in which such data was mined was to try to modeling students' academic performance based on grades, or if the students can pass or fail the course. By using such models, we can improve the quality of the education process and then increase the retention rate of the students. By building such a system, we have to collect the data, obviously, but then we have to take some steps like feature engineering and reduction, model selection, and improve the prediction models by hyperparameter tuning. These steps involves knowledge and expertise and can be quite hard to do. And we did a previous experiment in which we built such a model, but now we want to try to see if hyperparameter tuning can be used to improve that performance, to see if can be done better models for prediction. So the previous experiment was used for student performance classification problem, when we have a binary classification problem with one label for the students that are not at risk and 0 for the students at risk. And we compared 5 common classification algorithms used in educational data mining. From this experiment, we're going to reuse the data collection, the pre-processing, but we're going to modify the third step, that model training and cross-validation is still in place, but we add the hyperparameter optimization tuning. So the old experiment, it's based on the data collected over a period of 9 years, from 2009 to 2017, from one specific course, the object-oriented course, which has a special kind of evaluation process. It's a distributed examination pattern, where the material is split into halves. The course has 9 course sessions, 14 practical activities meetings, and 4 examinations. The students are considered to pass the course if the grade is greater than 5, or equal to 5. This is standard for European Union. The pre-processing, the data collected was about exactly 1,077 rows and 43 attributes and 1 output class. After the data cleaning, the resolution on missing values and selecting some attributes that are considered specific for this problem and normalizing the attributes, we obtained a data set of 908 rows by 12. After applying univariate statistical test, the features were reduced to 7. We then take an approach where the data set is split in 4 time segments after 6, 8, 12, and 14 weeks in the semester in order to produce modeling prediction at an earlier stage. The last segment was dropped because it was too late to take action by the teacher to improve the student's performance. For the data mining step, we use 5 popular algorithms from scikit-learn library in Python. We chose the decision tree, extra trees, random forest, logistic regression, classifier, and support vector machine for this job. The data is imbalanced, obviously, with a minority class of 40%. To compensate that, we use weights assignment for the classes in order for the algorithms to perform better. The metric to evaluate the models were true positive rate, true negative rate, accuracy, precision, and F1 score. Because it's not a large data set, we use stratified 10 cross-validation to evaluate the model, and to see if the models generalize over the period of over the years, we use a leave one group out strategy. So in the AutoML strategy, what did we change? We tried to use only the hyperparameter tuning for this task. We use the library that extends the scikit-learn framework with auto-scikit-learn toolkit. From that, we use the auto-scikit-learn classifier, but we set it to use only one estimate, the one that we want to test, with pre-processing disabled because that step is already done by us. We didn't want the algorithm to interfere. For the optimization metrics, we used balance accuracy because the data set is in balance. And the algorithm tried to optimize the following number of hyperparameters for each algorithm: 4 for decision tree, 5 for extra trees, 5 for random forest, 10 for logit, and 4 for support vector machine. We set a time limit of about 1 hour for each model trained in order to limit the time needed to accomplish the experiment. And what are the results? The experiment has two parts: the 10-fold cross-validation model training and the stratified and leave one group out validation method. For the 10-fold cross-validation results, we can see here, the original set is on the left and the AutoML version is on the right. With red is the original is better for that specific metric. With green is for the AutoML is better, and the gray box is the best outcome from both. We can see a large improvement in true negative rate that ranges from 1% to 26%. But the accuracy is improved, especially is statistically relevant improvement for all the classifiers, for the second time segment and the third time segment, where p-value is lower than 0.05. For the leave one group out validation, we can see the same pattern when true negative rate is improved, is greatly improved, but accuracy is the overall improvement for all the algorithm used is only for the second time segment. P-value is low enough. For the discussion part, we demonstrated that AutoML strategies in hyperparameter tuning can produce better results, and a big improvement can be saw in true negative rate, but evidently with poor results in the true positive rate. The linear regression classifier and support vector classification scores are mildly improved. The other three algorithms improve much more. The metric that incorporate the true positive and true negative rate accuracy and F1 scores are improved, but especially in the second time segment and in the third. So after the 8 weeks are better models. And one of the best outcomes that we saw is the closeness of the accuracy, especially in the second time segment, because then the practitioner can choose what model to use. In this case, decision trees is more interpretable, so the teacher can see why that algorithm chose the decision to mark a student at risk of failing. What are the limitations? We optimize the hyperparameter tuning, but in order to compensate the imbalance in the data set, we use the strategy of using the optimizing for the balance accuracy metric. But this is done to compensate the weighted of class in the first experiment. One limitation is the time needed to accomplish training the model. So depending on the pipeline used for production, this cannot be used in practice, because to train all the models, for each experiment, for the two parts, the algorithm took about 20 hours compared to 20 seconds using an original experiment. For future work is to test the rest of the AutoML techniques that to done pre-processing, feature selection, and so on, in order to improve, to see if that steps can produce the same or greater performance in the final outcomes. These steps is necessary in order to build a system that can be integrated directly in the learning management system. At the moment, in Moodle, from Moodle version 3.4 forward, there is a supervised learning framework integrated directly in the framework, in the LMSA, the Moodle LMSA, and that can permit us to integrate a microservice that can do classification algorithm or other educational data mining techniques in order to feed to the teachers good models. For conclusion, we started from original experiment in which we use AutoML hyperparameter tuning to try to evaluate if that can improve the performance of the models trained. We saw big improvements in decision tree, extra trees, and random forest classifiers, and in general for the time segment 2 and 3 in these cases. Thank you for your attention. Any questions, comments, and suggestions? If I have time, I'm happy to answer them now, but if you don't, you can send them to the posted email.
Thank you, Bogdan. Maybe we have some questions. Yeah, please. Could you come close to me? Please do some picture. Okay.
Hello, Bogdan. I have a tricky question. You showed the number of parameters for your models. It was like on one slide with number of parameters for random forest, number of parameters for decision tree.
Hyperparameters, yes.
Yes, so is that a mistake? Because I saw that logistic regression in your case has 10 parameters to tune. That puzzled me.
Yes.
What kind of parameters are these?
I don't know what kind of parameters, because that was that were extracted for the AutoML framework that we used. They reported that they optimized the algorithm for 10 hyperparameter tuning in that scenario. I think it's based on the implementation of scikit-learn in Python, and they have 10 parameters in that proper classifier.
Okay, Bogdan, thank you. And
thank you.
More questions? Yeah, please. But I would like to invite you because it will be, I don't like to run to each hour. It's some exercises for you.
Good afternoon, Bogdan. Well,
hello.
I'm wondering, you made quite great experiment on students, so could you, are you not afraid that the lecturers will be not necessary, just the students will start self-assessment in Moodle and that's all?
Okay, yeah, but I think that's important because...
So, well, we should be quite afraid?
No, I don't think so. But I think if the models that train or predict the success of a student can be interpretable, so we know why that model made that decision, we can feed the students or inform the students what they are doing wrong. They're not accessing a particular resource, they're not accessing at the right time the resources in the course. We can see patterns and identify the problems and inform them what they are doing not right. They are not doing correct tasks. In order for them to correct them, I don't think the teacher is going to be removed from the process.
Okay, Bogdan. And I would like to tell that Vitian he is the teacher in fully online master's degree program. It was as a provocative question. Okay. And now I have fantastic news because I was right that I informed that it's fantastic session. Our presenter from Germany, he came and he want Klaus North, he want to make presentation. Floor is yours, Klaus, and you have 15 minutes, 12 minutes, it would be nice. Yes, please.
Yes, I'll prepare everything. Can you see my screen now? Can you see my screen? Yes. Presentation mode, yes. Okay, sorry for being late because I thought we would start at 13 hours German time, and you know you are 1 hour ahead from us. So sorry for being late in the session. I think it was quite an interesting last question about do we need further people lecturing and teaching? Yes, I think we need them. But more as a question of a guide or an person who creates orientation in this learning processes. And my talk will be basically on the question of how to create the right framework of what we want to have the people learn, which competencies we want to develop, because I think this is a first step before then selecting learning resources. And I will talk about an ongoing project, which is called the AAL project, where we will provide resources and guide particularly to small and medium enterprises, but also to students in order to learn about digital transformation of enterprises. It's a paper which has been written by a number of colleagues. Daina, also from Kaunas University, was in the team and is also in the project. Let me first quickly address the two main questions which I would like to discuss today. So the question is, which competences and skills need SMEs and workers in SMEs for digital transformation? And secondly, how to design and evaluate curricula to meet these requirements. So we need a framework or a structured approach to that. In order to do that, we have this Erasmus Plus AAL project, where the objective is to increase not only the awareness, but also to make clear what are the competencies firms and students, learners would need in order to successfully go through digitalization, digital transformation projects. And one of the outputs is a digital transformation curriculum. We have a consortium of a number of universities. Here you see from Europe, and we are now at the mid of the project. And I just want to report about this output too, which is related to the curriculum development. And we start in our project with a common joint framework, which is a so-called DICRO Digital Maturity Framework, which looks into the challenges and needed capabilities of firms or organizations to successfully transform or grow according to using digital technologies. And we built this on a common known theory in business, which is called the dynamic capability theory, which basically states that firms need to have a number of capabilities. First of all, they have to have a capability of sensing, which means in our case, sensing digitally enabled growth potentials, which means you have to understand what technology offers and what are growth potentials of the market. Secondly, you have to be able to develop a digitally enabled growth strategy in the mindset, because if you do not really understand what's behind it, you will not be able to have a digitalization successfully. But understanding is not enough. In a third step, you need to be able to seize, to take advantage of these growth potentials, which, for example, calls for digitally enabled business models as one of the main points which you need to be able to develop. And as a basis, you have to manage your resources for digital transformation, which means digital skills and learning, and have the right competencies in order to do that. So this is our main framework, which has been improved, which has been applied to several hundred companies in Europe. And we link this framework to another framework, which will come in a moment. So the idea is, based on this framework, to design a digital transformation curriculum or the basis of it, which means we need a competence model for that, and we need to have developed some guidelines for training programs and to implement it. So this is basically the steps which we are going. And the aim is to assist higher education educators to design or redesign learning programs and to develop advanced digital skills in this area. What we do is we link our framework, the DICRO framework, to another well-established framework, which is a European e-competence framework. The logic behind the e-competence framework is different. There it's a logic of a framework as a reference model applied within the information and communication technology sector, and it follows a bit a logic of an IT project. You plan, you build, you run, you enable and manage. This is already clear that this is not in all aspects congruent with the overall objective of developing a digitalized business, where you have certainly components and projects, but you will see this in a moment that this reference model is only tackling with some of the competencies which you need for digital transformation. And if you talk about competence, we talk about a demonstrated ability to apply knowledge, skills, and attitudes for achieving observable results. Basically, competence, in other words, is being able to doing the right thing in the right moment, based on what you know and what you have previously done. So let's link now the two frameworks, which is the DICRO framework, the 4 steps which I've explained, and the European competence framework. And as you already see, is that the competence framework is not evenly distributed in all aspects. It has a heavy bias on basically the agile deployment of initiatives, this planning doing on. But in the new current version, you've got also some aspects which are important, which is, for example, business plan, the competence of business plan development or digital marketing, channel management, and so on. And we added, where you have no numbers, we added also some new competencies which have not been considered in the European framework. And as educators, you are also free to use this framework, but also to aggregate other competencies or take the competencies out. So it's basically a way of systematically going from the task of digitalization to the competencies needed. But the question is now how we go to the next step, to a step of developing skills and competencies in these areas. So what we've done is we have developed in more detail a competence model, which basically starts with the 4 steps of the DICRO framework, so which we call competence areas. So enterprises, firms should be able to sense digitally enabled growth potentials. They should be able to develop a digitally enabled growth strategy and mindset. They should be able to seize growth potentials and to manage resources. And in order to do this, we have defined basically modules or objectives, which we call here competence categories. To sense, I just give you an example. In order to sense digitally enabled growth potentials, you have to be able to understand and monitor digital technology and their business potentials. This is part of it. And secondly, this is a technology push part of it. You have to be able to develop digital customer needs, which is more the market pull which you have in this area. And in order to do so, you need a number of competencies. I have put the full list of competencies here. For example, technology trend monitoring. The competence of technology trend monitoring would be important in order to understand and monitor digital technology and their business potentials, similar to all of the other things. And then learning, if you come to learning, certainly you will have to create the right environment, the right resources, the right simulations. For example, we will have developed a simulation lab in the VOID project where you can simulate technologies in order to get an understanding. And students would, coming back to the question at the end of the previous presentation, students then with or together, supported by the educators, would develop their own competence model, what they want to learn, and then we would select the resources which are necessary. This might be formal courses, but it might be also personalized, customized learning journey which we offer. So, and going a bit deeper into this model, what does this mean for each of these areas of the area competence areas? For example, we take out now, going back, the first competence area, sensing digitally enabled growth potentials. If we take it out, we have these two sub-categories of competencies. We have related competencies, examples of that, and we've defined learning objectives. So to understand monitor digital technology and the business potentials, what do you need? You have to understand the main digital technologies and their application, assess their business potentials, and monitor technology trends. How to do this? You can use our DICRO assessment of digital maturity. You can do it, for example, by simulators, by algorithms. So as I gave you an example, in order to get the right resources to develop your competencies in these areas. Once you have simulated, for example, blockchain in a number of simulators, you might have an idea what is in the blockchain technology for your business, or as a student, you get better understanding and can relate it to a practical application. This we've basically developed in our framework for each of these four competence areas. From this competence model, which we've developed, the competence areas, categories of competencies, we are in the process of developing some strategies and guidelines of learning towards self-directed learning. And we are basically creating an instantation which leads to the definition and selection of actual modules, learning objectives, learning experience, and courses. So the model which we have developed can in reality be used for different purposes. It can be used for the purpose of designing curricula, to think, does our curriculum basically have all the considers all the competencies? We might select some competencies, but we might use it also as an orientation for learners to guide them and help them in their assessment of their competencies and provide learning resources in which they can later on develop their competencies, guided by educators in different manners. An output, or one of the organizations, how we'll organize it, we will have a number of labs. We will have a curriculum development lab, a simulation lab, and so on, an assessment lab on our VOIL platform. And for example, if you have selected some of your competencies which you will want to develop, you might select available resources. For example, you might select the blockchain simulator, and you would put the blockchain simulator here on from the right side to the left side, and basically design your own curriculum based on the competencies which you want to develop. This is one of the areas. You might also have develop a competence matrix of different persons where you can select your competencies and put together your competencies which you want to develop. So it's rather a personalized approach which follows an overall framework of developing digitalization competencies for organizations and training students in order to have this be prepared to assist organizations in this field. This project is still an ongoing project. We still will have to test it as we've got half of the project done. But the idea is that in the coming months, we will test this approach. We'll try it out with students. And from this, we will come up with a more mature approach of going further into this. This is basically what I wanted to tell you. And perhaps it's a bit a diversion from what you are normally discussing in this session when you're talking about software. Here we are talking about basically the framework which later on your e-learning components would fit in, and you basically have a meta structure which could work together. So thank you very much, and I'm open for questions and for discussion.
Okay, thank you, Klaus. And we have a remote question. Mr. Klaus, are the mentioned resources open online? from your project?
The resources are not yet online because we are in the process of building the platform. I think they will be online for testing at the beginning of next year.
If I am understood correctly, when you finish your project, it will be all the resources will be online, yes?
Yes, and in the meantime, we will also have experimental stages. You can already go to the Voil homepage where you get already some resources where you can do your assessment or whatsoever. So step by step, launch and iterate, we will go into it and develop it further.
And one more question. Could you see some examples? What simulations are you suggesting?
Okay, this is quite open. At the moment, we are quite heavy on blockchain simulations, and on the other hand, on Internet of Things simulations and some process simulations in the context of Industry 4.0. But it's not limited. We might provide some resources on our own, but we might also provide some links to existing simulators. The idea is that basically this grows, this is a database which grows of resources, of simulations which students and firms can explore.
Okay, Klaus, thank you very much. Exactly like in German time, 0000. Thank you very much. Perfect. After virtual trip, Bulgaria, Romania, Germany, we are coming back again to Lithuania, Kaunas, and now I would like to invite our next speaker, Tomas Danikauskas, a case study of applying gamification in teaching project management. Please, floor is yours.
Hello, good afternoon. Sharing screen on there. Ne, matot, aš pašėrinsiu, bus problema tame, kad aš padarysiu full screen ir man atrodo, ar ta aplikacija. Dabar matos ir ne, manau? Okay, good afternoon. I'm Tomas Danikauskas. Here in presentation you see there is all our team which worked in, was working on this project. All of us are from Kaunas University of Technology, and I will present to you a case study how we succeed with applying gamification in project management subject. Like in previous presentations, we have seen the importance of gamification in education is really rising up. Of course, it increases technological abilities to develop a variety of gamification solutions, like was presented by Thomas' team. So we chose maybe a little bit lighter variation of gamification. When we did analysis, research, what we could do with gamification. So we find like 3 strategies of game applying in education, like gamification, game-based learning, and serious game. Serious game we skip it exactly because it's more oriented to specific skills practice, like in defense, medical. Of course, education too. We can make some games for specific tasks, subjects, learning. Game-based learning, of course, like I mentioned in a slide, that is more based for particular tasks, learning on games. So we choose the gamification, and gamification for 3 main elements needed in our game was like components, like badges, levels, some
leaderboard to make this game more attractive, to make all participants see what is going on around you when you're playing game. Most important part is mechanics, or feedback, communication, challenging, and of course, in all games you need dynamics. When we were analyzing how games and gamification are applied in education, we're finding a lot of board games which are not computerized, but really nice applied, and what we missed in all those things were instant feedback. So we tried this model, make computerized, and applied it not for all project management subject, but especially for added value analysis method for project management. All this method is based on 3 key metrics like planned value, actual cost, and added value, which is determined and calculated over the project management. In the game, we used association, repetition method, providing examples to students reach not only play, but to have ability to understand, to be introduced to all definitions, concepts, and formulas. And of course, it's a role-play game. We choose internet-based gamification strategy. We released a game where students can choose from few subject areas for project management, like in case we have like a warehouse information system development, a hotel, medical enterprise management, and management information system development. Then each student receiving a task list with hours needed to develop a project. Then they need to apply some resources to projects. They all have a budget of projects, so all student has unique model, unique game conditions. And after that we have a play board where divided all board in 4 categories. We have 4 categories like task, definitions, or concepts, where users or students receiving more questions about how they understand and know concepts. Second one is formulas, calculations, where they need to apply right metrics to calculations to receive correct derived metrics. Then, let's say, a little bit harder is problem-solving task, where they receive some context, but context is took from each own project managed in the game. So from the context, they need to calculate some metrics. They need to choose right formulas. They need, again, choose right metric values to find those metrics and evaluate own project. Last one, four type of task. Fourth is a graphic task, where they're receiving a graphic, and from this graphic again is made from project which they are managing. So from graphic they need to take right values for some metrics, calculate again derived metrics, and all it must be presented. After each, like all board are derived in 4 parts of questions, from easiest like concepts. So from 1 to 10 we have easier part, from 11 till 21 we have already calculation formulas, then till 40 we have all tasks problem solving, and last one is for graphics. In each this part, every time we have some repeating of definition and concepts, and we are looking if student making some mistakes with some concepts, we again giving him chance to repeat it, to remember it. Of course, all over the game, he has Gantt diagram, will he see how actually is going his project, according solutions he made. Like red line means where actually must be a project, and blue color means where project is now. So he actually see all other, and other interesting thing what we applied to our game, when you're rolling dice, from 1 to 4 points, they playing board game. If they receiving 5 or 6, they getting a risk card. What does mean risk card? They receiving some risk in real situation, like saying, we have some crashes in server for 5 hours, what we will do in your project, what you need to change. And if they have 2-3 options to choose what to do with the project. Slow down some works, stop some works, or apply some more resources, and dependently from what they choose, changing all activities in Gantt diagram. They receiving level, they see how many points they received, and over the project management time, they see the budget, how changing budget. If they applied new resources, budget can be decreased, or they can save budget if they changed expensive resources to more cheaper resources. So basically, that's it about the game. The game was applied in 2019 autumn semester. We measured motivation and experience of game of students. For experience, we used instinct motivation inventory scale, and for experience MEGA scale, we little bit adapted scales, because like we see, we have value from 1 strong disagree with 5 points mean strong agree. We reduced, like in MEGA it was 7 options, to make all more similar over both methods. And basically what we could say is that after midterm exam, where students got some tasks with like added value evaluation analysis method, we could say that results were better, like in previous year, where they just got theoretical knowledges and didn't got ability to practice, to understand, not receive just information, but receive knowledge. Because especially when we're working on like graphical and problem solving tasks, they really receive knowledge, how to work with those metrics and what to do. And if we see like motivation and experience from 1 to 5, so we see that it's experience and motivation is above average, it's increased, and when we did research on other papers, like we see that in our case, midterm exam score rise from 7.4 to 7.5. We found some research papers like in Colorado, Denver universities, where they saying again that score of students exams increased like 14% higher than without using gamification. So we see that this is really important and nice to have such tool for education. And another case, like we see, is that in the case of, like we got now a lot of distance learning, because virus. So this gamification really is needed. And in conclusions, let's say what we can say is that really students evaluated positively our game and all gamification tool. What we see from our point of view that gamification is really suitable for teaching subjects who need understanding of metrics, repetitive calculations, to involve student in subject and to receive knowledge of application of your knowledges. Of course, gamification increased students' motivation to work on the subjects, and for future works, what we see would need integrate into game, need direct communication. Some tools like if we see in entertaining games now, gamers use like Discord platform for communication. Something is needed in gamification too, because actually when playing students, they need to see that they are not single at the moment in playing. They need to see that some colleagues too playing. They need to contact to share knowledge what they received actually at the moment in a game. So that's it. Thank you for your attention, and please questions.
Yes, please. Exercise. Bring. Because I'm so lazy
Thomas
to go.
wants to ask Thomas.
Okay.
And yeah, it's good because during the conference we are getting familiar to what's going on in our university.
Yeah.
So my question is it your creation, this tool?
Yeah, it's created by our students.
And
Christina participated directly to development of this game.
And for what platform did you use, or you just?
Okay, it was developed, front end was developed on React, for database basis regularly it was used MySQL, and I think JScript some for background was used. Because it's not so interactive like your games, so we technologically don't need so advanced tools and technologies.
Okay, and last question regarding your thoughts about integration of communication tools.
Yeah.
Maybe you do other way around. You integrate your tool into something like a gyro system.
Yeah, it could be. Yeah. It would be maybe it will be better than develop another new communication tool. Yeah, it would be better this game to develop because those communication tools are more widely used, so it's easier to integrate just the game. Like in a Moodle, we could make like a module to integrate.
Okay, thanks, Thomas. I see.
Thank you.
Questions.
Okay. 1 minute, please, because we have to answer to this question. 14 increase give 8.5. You got
no, 14 is, like I said, it's not in our university. We like said, just find in other papers that it increases 14%. In our case, yeah, it was a little bit different.
Okay, and the last more important moment.
Thank you.
Picture. I'm joking. Okay, thank you.
Okay, thank you.
Thank you. Yeah, thank you, Thomas. And now I would like, because we have not only one presentation from Greta Volodskaite, but we have +2 from the previous session. And now I would like to invite Greta Volodskaite and presentation about design of the platform solutions to increasing opportunities for low-skilled women. Of course, it's not about us, I think. Yeah, please.
Okay, let me share my screen. All set, right? Okay, so good afternoon, everyone, the ones who are present here and the ones who joined the conference online. My name is Greta Volodskaite, and today, actually right now, I'm going to present you the paper which we've wrote together with an associated professor, Danguolė Rutkauskienė. And the title of our paper is Design of the Platform Solutions to Increase the Employability and E-Learning Opportunities for Low-Skilled Women. So we did quite a research, and a lot of authors, as Asadi in London and Mackenzie, stated that a good match between the skills demanded by the labor market and those acquired in training is important for promoting strong and inclusive growth for women. And it is because female human capital accumulation has a considerable impact on technology, adaptation, innovation, and economic growth. And although women are beginning to achieve gender equality and close the gender gap in an IT sector by developing digital fluency, they still remain underrepresented in many developed countries all over the world. The other authors, such as Gandini and Pai, stated that the nature of jobs is quickly changing due to automation, social and economic factors, and it is difficult to predict which skills and which jobs will be demanded in the future labor markets, and thus threatening to widen the skills gap and making the career planning more difficult. And at this point, these authors suggest that the profiling tool is one of the most reliable methods here to solve these solutions. And all of these studies show that the systematic approach when setting priorities and analyzing the needs of women, stakeholders, training organizations, and employers, at the same time providing them some external help like a mentoring platform and communication tools, is the best solution when trying to lock low-skilled women in the tech sector and to prevent them from dropping out in the middle of trainings or at the beginning of their career. And technologies at this point here plays the crucial role because it's the easiest way actually to gather all parties and the women, stakeholders and employers into one platform where the needs of the labor market are covered by the training organization specialists who are working and specializing in that field with these specific job profiles and who are following the newest trends and the newest skills needed in the future markets. Platforms consisting traditional learning and virtual learning methodological approaches help to assess the needs faster, easier, and in the most accurate way. And tools like profiling tools or gap analysis tools and mechanisms help to match people with the job profiles which are the most related to their competencies like knowledge, skills, and abilities which they already have, and behavioral actions and beliefs and attitudes. So to match these ones with those required in the labor market. And these tools combined together can help to do it very fast and in an easy way. So based on the research we did, which was quite a huge one, just presented it here very briefly, we developed the profiling tool based on the four-staged waterfall approach, which you can see in the slide. And the first was an online employability profiling tool to identify the user existing skills, competencies, attitudes, and experience in line with e-competence framework, digital competence, social and working skills framework. And these combined with the age, personal goals, and formal education place the user in an employment matrix. A digital employability pathway defines what individual training needs, experiences, and work needs to be undertaken to achieve these goals. The second was an employer co-designed customized learning plan, which is very crucial here because sometimes the general statistics from the labor market, from the tech sector statistics does not show the real situation, and just the direct feedback from the specific employers in that sector is the better version of it. The third one was the recognition of user training skill and experience or prior experience learning. And the fourth, a job application and onboarding support system developed to assist each individual with transitioning from an unemployment status to a successful first step into a digital job-related employment. So the learning is hosted mostly on the platform, but it will direct the user toward external learning materials if it's needed. And the platform is accessible anytime, from anywhere, online, at any time, and from anywhere, any place in the world, through any smart devices. And the face-to-face courses already is a part of the offering here because we're following the blended approach again. And so the aim of this profiling tool is again the comparison of person's skills, competencies, and behavioral attitudes they have to do the comparison of those skills the person has with the skills the job market is needing now. So an analysis of the most appropriate profile structures has been made, and profile structures matches e-competence framework, digital competence, and social working skills framework requirements, as well as employers' requirements collected during the needs analysis process. And women profiles and job profiles have common points to be matched and to be matched together to be able to perform gap analysis and serve as a reference when developing the training roadmap. A profiling tool performs an assessment of the individual's skills, competencies, and experiences via an intuitive self-evaluation test or self-assessment of the user and presents the results to that individual. First of all, the collection of the requirements was done using already existing data, followed by analysis of all data acquired before the research, and digital job profile requirements were specified to create requirements specifications, and profiling tool design consists of that requirement specifications, which leads to creation of job profiles design prototype. Simultaneously, gaps analysis tool and training program platform were designed, and after the designing phase, profiling tool was integrated and broken down into 3 gaps: job profiles tool, gap analysis tool, and training program platform. When talking about the data, how we're gathering data and how the data stays up to date through all the living period, the profiling tool is fed with taxonomies from ESCO, ECF, and Digicomp. Job analysis results including job level and work context, employers and stakeholders' perceptions regarding existing and future trends, as well as current job holders' experiences could also be considered when linking existing classifications frameworks with evidences from the different national settings. Prioritization of suggestions could also consider job seeker preferences and employers' attitudes regarding specific competencies. Taxonomies from different sources for profiling tool were preloaded by hand or, like at the ESCO case, by single or multiple APIs. The profiling tool and gap analysis tool were integrated to provide the matching results, and the gap analysis tool measures the actual competences for a job profile and gives a feedback on 2 things. The first one is a woman actual profile, so skills and competencies and behavioral attitudes which a woman already has and is developed, and the second is the gaps where competencies are below norm by suggesting the new training roadmap to gain new necessary skills and competencies. The purpose of the gap analysis tool is to match job seeker profile with occupations and job profiles to give insights on job women is matching the best. And by the best match, we mean that the current women knowledge and skills she already has are closest to the market needs and will require minimum efforts to fill in the gaps and to get employed very fast. The purpose of the training roadmap is to fill the gaps and to get the job, of course. So job seeker considering gap analysis results, existing job profiles, and ESCO occupations where relevant builds a task list to achieve the goal. The profiling tool and the gap analysis tool are integrated and providing matching results again. And the training is, as I said before, mostly hosted on the platform by the training roadmap created. But if it's needed, the mentor and the trainer can redirect user to external training sources. So all in all, after the huge research, we developed the profiling tool and gap analysis tool, which are integrated to providing matching data results, which later are incorporated into training roadmap. And the platform is accessible by individual women who will use it in a self-placed mode based on self-assessment, but it also could be used by the group of individuals in one location participating in some guided or mentored session. The best model to reach women, assess their competencies, and train for future work requires these several methods: profile framework, profiling tool, gap analysis tool, training roadmap, and collaboration with the target groups, which are a crucial role here, because if you will work mechanism with these target groups. Like the target group is not only the women or the employers, it's the end target group, but also the stakeholders and the training organizations are also very important to take into consideration when locking women, low-skilled women especially, into tech sector and not dropping out of the trainings. And profile framework matches e-competences framework, digital competence, social and working skills framework requirements, as well as employers' requirements collected during the needs analysis process. So all in all, profiling tool to check skills, competencies, and experiences gaps, and to help to build a roadmap in order to become suitable for selected job profiles. So the woman basically takes self-assessment tests, evaluates their competencies and knowledge already has, and profiling tool evaluates that and suggests you the best matching job profiles and the worst matching job profiles for you to choose. Then the gap analysis tool enters, and its main purpose is to set goals, create tasks, and to achieve those goals and to track the progress. So after the user has the suggestion of the best and worst matching job profiles, gap analysis tools at the same time explain you what competencies you lack of, what competencies you have, and where you have to train the most. And after that, the training roadmap is generated, and it specifies on what training is needed in order to potentially fit in a desired job role. Also provides tools to monitor the progress, allow to set deadlines, tasks, and completion status. So training roadmap is generated based on the profiling tool results, based on the gap analysis results, and it's generated automatically on the platform for each specific user based on their competencies. And then the deadlines and the tasks and the tracking system is mentored by the mentor and by the training organization. And this proved working very well, as the increasement and the enjoyment of learning of low-skilled women was increased in 2 months by 15%. So yeah, that's it for me. Thank you.
Questions?
We have 2 questions from participants.
Could you read yourself? Yeah, this one.
The last one.
Could you explain what do you mean, beliefs and attitudes in your slide? Oh, okay, so it's basically the not skills what you have. It's the, for example, I'm more attracted to some creative tasks, and some people are more attractive to analyzing data or whatever. So this is the just some knowledge human not knowledge even, desires, attitudes, behavior, like what you like to do most.
Thank you. And one more. Can you explain taking ESCO into project? Sorry? Taking ESCO.
Can you explain taking ESCO in the project?
Yes.
Could you specify that one?
Some model. Okay, maybe next time. Okay. Thank you. I don't know why we see Bogdan so big. And now, as you know,
I'm sorry, the certificate for
sorry.
author, it's for you.
Thank you. Thank you. We will share.
Thank you.
Thank you.
Thank you.
Yeah, thank you.
So much.
Okay. And now we have 2 presentations more. And do you know, I'm a mathematician from last century. I have some paper. And I'm not sure, but we will try to be in time. And kindly, and now I would like kindly ask our next speakers to have maybe not 15 minutes, but 12. I think it's as some, how to say, agreement among us. And now I would like, of course, I want to see Martin Witte. Yes?
Yes.
Floor,
thank you very much.
Floor is yours. And as you, I think we can hear you, we can see you, and you have 12 minutes. It's okay?
Yeah, of course, of course. I'm going to I prepared a brief version of my slides, so I hope I will fit in time. I apologize once more for being late, so for missing my time slot. And I will jump directly to my presentation. So can you see my slides?
Yes, you can start.
Perfect. Thank you. So I'm going to talk about cross-lingual metaphor paraphrase detection, and I'm going to present experimental corpus and some baselines. I will start with the notion of paraphrase detection task. It's a binary classification task for sentence pairs. And the question is whether two sentences convey the same or almost the same meaning. It's a quite important task in NLP with many downstream applications like text summarization, sentence compression, plagiarism detection, question answering, and other tasks. This task is closely related to natural language inference, formerly known under the name of textual entailment. We can consider paraphrases as bidirectional textual entailment between two sentences. Paraphrase detection is intensively studied problem for more than a decade. Another task I'm going to talk about is metaphor identification. So if we use language, we use it in two modes, in figurative and non-figurative mode. So, for example, if we have some expression like sweet child, we use the word sweet in a figurative way, and when we talk about a sweet apple, we use it in a non-figurative way. Figurative or metaphoric expressions are naturally present in narratives and in many common documents that are automatically processed, like newspaper articles, headlines, and so on. I took one headline from New York Times, and there is something like Republicans are eroding one of the core institutions of American democracy. So this is a figurative or metaphorical expression. Metaphor identification or metaphor detection is getting growing interest of NLP community. For example, 2 years ago, figurative language processing was organized as a collocated event of NAACL conference. And now I'm going to do some merging. I'm going to talk about the fusion of these two tasks. And the task is called metaphor paraphrase detection task. It's a merged task. It's task to decide whether a given sentence containing a metaphor convey or not convey the same or almost the same meaning as a given sentence with no metaphorical expression. It's something like explanation of some metaphorical sentence. This task was introduced 2 years ago, and the original setting was monolingual. It was done in English. It was introduced 2 years ago by Bisoni and Lapin, and they presented a manually annotated corpus of sentence pairs, approximately 750 items. And this corpus contains sentences The first sentence is containing metaphoric expression, and a sentence with without metaphoric expressions, plus an integer label. And the meaning of integer labels is described in the following list. Label 1 means that two sentences cannot be considered as paraphrases. Label 2, the sentences cannot be considered as paraphrases, but they show a degree of semantic similarity. So, for example, they use the same words. And 3, label 3, two sentences could be considered as paraphrases, although they present some important difference in style or content. So they are not strong paraphrases. And label 4, two sentences are strong paraphrases. So the meaning of the metaphoric and non-metaphoric sentence is equivalent. Their approach is based on Siamese neural networks. The architecture is covered in their paper. The encoders use convolutions for encoding, and not the normal encoding, but heteros encoding with some delays. By the way, this corpus is available for free download. I'm going to jump to their GitHub. Maybe you can see some examples. I'm going to make it bigger. So here we have an example of an item. A metaphoric expression was she was the light of my life, and then it's accompanied by four non-metaphorical sentences with labels assigned. So one, she brought, and so on. Well, so this is the example of the monolingual corpus presented by two authors 2 years ago. I will go back to my slides and so here is one more example. Reference metaphor sentence was the crowd was a river in the street, and paraphrase candidates with corresponding labels are presented here. So we can consider this task as a regression task, or we can transform it to a binary task. So positive examples will be those labeled with 4 and 3, and negative examples. Oh, there's mismatch. Well, yeah, it's correct. It's correct. Pardon, sorry. So we can transform it to a binary task with grouping these two labels. And what's my part of research? It is shifting to a cross-lingual setting. And the task formulation is quite similar. I've tested it on a Czech-English language pair in particular, and the task is to classify sentence pairs such that the first part of the pair is an English sentence containing a metaphor, and the second sentence is a Czech sentence with no metaphorical expression. The corpus was derived simply by translation of the original corpus of Bisoni and Lapin, and It was done using manual translation, and the key fact or the cornerstone is that the labels are somehow invariant with respect to any translation of the non-metaphoric sentence. So we can simply use the original labels. So here is an example item of the translated corpus. The premise or the first metaphoric sentence is the faculty meeting was an easy breeze. And the hypothesis or paraphrase candidate is schůze fakulty byla klidná. So English translation is the faculty meeting was calm, and the label is true. So we can consider these pairs, the sentence pair, as paraphrases. We try to check the correctness of the corpus, and we have made some quality test or evaluation. I'm going to jump quickly through our approaches. We used machine translation back to English and use the same Siamese networks as in the presented paper of Bisoni and Lapin. We try to use universal sentence encoders, and then we experimented with a multilingual embeddings approach. And the result was a bit surprising. We achieved in 12-fold cross-validation accuracy of 58.20%. So it's close to the baseline because the corpus was more or less balanced. So this is the result. So the summary is that we have stated a cross-lingual metaphor paraphrase detection task. We stated some baselines, and the corpus is now also available for public in my GitHub. So if you want to experiment with Czech language, you can. So time is over. So thank you for your attention.
Pressed. Oh, I need some lunch.
Oh, of course.
Because I pressed, but it was not successful. Thank you. Maybe some questions? I'm looking to you, Ratiev, because I'm sorry, but my knowledge was not very deep in these areas. Okay, thank you, Martin. And now we are coming more and more close to fantastic event, Best Paper Awards. But before that, we have, yes, I know. But before that, we have one more presenter. I try to check who will do.
Hi.
Oh, Johan Kersling? How to
Joshua
pronounce your name?
Right.
What is your name?
Joshua Kersting.
Joshua. Okay, thank you. Now you have 12 minutes, and of course, according to our rules, it will be not questions, because you survive until the end of our conference. And please, floor is yours, 12 minutes. Okay, Joshua? Thank you.
Okay, I have to shut down Zoom for a second and come back. Sorry. So now I can hopefully, yes. Can you see my screen? Okay, so here's my presentation. It's called Take Me If You Can. We are dealing with user-generated news articles, and with, those are peer-to-peer news that can be written by ordinary authors. Usually they base their articles on well-known articles from pages like CNN.com. And these pages were in Germany very popular, especially in the earlier times of the internet. Users were able to tag those articles themselves. So for example, political articles received tags with politicians' names, with countries involved, or with institutes. The challenge here is that we had over 5,000 authors, and these authors were able to tag the articles themselves. We had over 150,000 news articles written by users, but also 50,000 unique tags. So the question here is, how many overlapping tags have we? So are they all necessary? I don't think so, because 50,000 unique tags is a really high number. The problem is the users want two things. We want qualitative tags, so tags that describe the article well, but we also want others to find their articles. So in order to make other users find their articles, they use a lot of text for one article, and they write down every possible style of writing something just to have the best text in their mind. But leads to 95% of the text appear less than 50 times. And the question here that evolves is, how can we support this? How can we support users in tagging their articles? For example, by proposing article tags or by merging different writing styles. We have examples to demonstrate what we are talking about here. The tags are just based on text. They are not with any semantics enriched. We have, for example, the German Chancellor's name, Angela Merkel. There are different styles of writing her. So just her last name, her PhD title, her full name. The title of the Chancellor in German is Bundeskanzlerin. We have the same with, for example, the football club of Cologne, who is called Erster FC Köln, First FC Cologne. Some users write this together and they leave out a white space due to an error, for example, a typo. They publish this in 3 parts. The same comes down to foreign names like the terror group, who can be written like this with a Q or a K. So there are a lot of errors that come up or things that are intentionally done by the users. What we want is to have a tagging system that supports the users in this. Because so far, all those tags are not related to each other. Our solution is an orchestrated NLP service pipeline. So we started out with 39,000 tags and we ended up with 21,000. The different steps involve at first rule-based normalization. For example, leaving out punctuation marks. We had lemma merging, so plural and singular forms can be merged. We have entity matching, I will explain this later, and lexical disambiguation. This will also be explained in more detail later. And we have fuzzy merging, so something like a string distance. We also, as we ended up with 21,000 tags instead of 39, made some tests. So we trained models to label texts by themselves. We trained transformer models like BERT. I will explain some details later. What we can say is that the results on the peer-to-peer news were quite poor. This comes down that there are still too many labels and there's a low quality in labeling. But when restricting the data set, we had some reasonable results. So for example, leaving out labels that only appear 5 or 10 times at all in this large corpus. To test this system, whether it's generally working, we crawled another news website. So these articles were written by professionals and the texts were signed by professionals. And we were left with 21,000 texts for these professional articles. Restricted them, this corpus, to 21,000 texts and had a score of over 0.57, which is pretty okay. When we restricted the texts more, so at least 20 appearances were necessary, we were left with only 250 texts and results increased. So what we learned from this is it's hard to train a multi-label classification system for tagging, but it can work and it can at least support users. The texts that are proposed by such a system will not be perfect, but it can help us, for example, when we are tagging our article to get some ideas what we can use and what we should not use. I already mentioned the identity and entity matching. Because in news articles, we have a lot of names of politicians, for example. Those names will usually not be in lexical resources. For German, we have a Duden book, and linguistic knowledge is not sufficient here. We need semantic knowledge, which is incorporated in BabelNet. BabelNet is a large semantic resource that has word knowledge in it. It is able to merge very different entities but belong to each other. For example, abbreviations and the long version, which is really good for party names. In Germany, for example, every political party has its own name and its abbreviation. What BabelNet does is to assign a unique ID, the BabelNet ID. A good example is here on the right. We have the name of a politician from Egypt, and he was written in 4 different ways. Our first step in the pipeline was rule-based, and it merged already 2 of them, but 2 others were not merged. And BabelNet is able to recognize all 4 of them actually in this example and merge those examples accordingly. So BabelNet looks basically like this. We have the different writing styles, and they're all connected to semantic information like Egypt. This is Egypt's name in German. Furthermore, we have a disambiguation. It's interesting that ambiguity means one word can have several meanings, like bank in English. It can be a financial institute, or it can be the sandbank in the sea. Based on the context, human beings can differentiate that. Computer programs have a hard time with this, but it's nowadays a bit possible. At least BabelNet can do this because they have a service called BabelFi, which accesses BabelNet for doing so. The interesting thing here is to find synonyms. So when I want to take an article with the word suicide, in German we have 3 different words for this. And they're all used, for example, one is used 350 times, another one twice, and another one over 100 times. And as you can guess, this is an important and interesting tag. It would be good to understand that this word can appear in several forms. So there are synonyms who mean really the same. And we can merge these tags. There are NLP details about BERT. I mentioned this earlier. It's a transformer model for automatic tagging. It is transformer based and made for high performance because it's usually trained on a large corpus of text. It's a full language model, and it can produce semantic and context-based vectors. So the special thing about BERT and Roberta, which is an enhancement, is that it's truly bidirectional. It can use the context of both sides of a word, so beginning of a sentence and the end, to calculate its vectors. And it's the state of the art. There are many new developments for BERT, like SpanBERT or the StillBERT and so on. Interesting is here that we can fine-tune this model directly to produce a tagging system. We just add 1 layer and all layers of BERT are used and all their knowledge is incorporated in the result. We did this for our tests, which I presented earlier. We used the German BERT, which is trained on Wikipedia and news articles, so it's a pretty good match for our case. and used fine-tuning approach. Interestingly, BERT was better than Roberta. And if you want to have more detailed information on this, of course, I invite you to read our paper. So what is the conclusion here? We have bottom-up taxonomies, so user-generated tagging systems. They can work, but they scale very, very poorly. When the system gets larger, there are a lot of tags that are used just once or twice, and the tags that belong together are not merged. We can help with this by cleansing our tags. I presented our pipeline here. It does a good job. We can support the system as a whole by training a tagging system. So it's a multi-label classification problem, and users can get help by our system by proposing tags, for example, suggesting tags. But we have to admit, a high usage of resources is necessary. You need a lot of GPUs and a lot of training time, a lot of electrical energy to train a system that does a quite good performance. But it is possible, and this can reduce noises in data and provide a very good user experience in the end. So thank you very much for your interest, and if you have any questions, please ask.
Thank you, and applause. And before we are finishing, 1 minute, okay? I know it's a big gift for me, and this one, Thomas, gift, yes. I would like to tell only a few words, only a few sentences, not chapters. First of all, really, I would like to thank all of you. Can you sharing to close and to show all videos? Can you switch on your cameras? I'm sitting like this. I'm asking our remote participants. Fantastic. And really, I would like to thank to all of you visiting our session. We are number one. We had 8 presentations, and really I would like to thank not only participants in this room, but our speakers, our organizers. And this is, as you know, usually before our speeches, before some very intensive events, and especially during events, we are a little bit nervous and stressed, and we are losing sometimes a little bit our brains. For the reestablishing this, I would like to invite Volker's team to come here, maybe some representative. Volker, come here, 4 people. It's not video, not audio, I know some specific rules. And ladies, you are coming here. This is not technical assistant, they are our colleagues, and because of this team, it was fantastic service. Really, it was fantastic, and ladies, coming. You need some special speech. Yeah. I don't like this. Yeah. And your assistant. And really, I would like to thank to all of you, and of course, last speech from Professor Odris. Yeah.
Okay, so thank you very much. And this is your certificate.
Thank you.
And small souvenir.
No. Come in here.
Oh, okay.
Yeah. I like to be like this. Thank you. I'm joking, but it's okay. Thank you. I finished our session.
Okay, so let's summarize our conference results, and I would like to share the screen. So here we have the proceedings, yeah. Okay. I would like to share this one. How we can do that. So can you see it? Okay. So, so now it's time to award the best presentations of each section. So according to the meaning of the section chairs and the members of program committee. Now we will award the best presentations of each section. So from the section number 1, named Intelligent Systems and Software Engineering Advances, the best paper award goes to the article Military Vehicle Recognition with Different Image Machine Learning Techniques. Congratulations. Okay, so the best presentation paper award from a special session on intelligent systems and software engineering advances. So goes to, just a moment. Yes, goes to the publication mining data with many missing attribute values using global and saturated probabilistic approximation based on characteristic sets. Congratulations. And today's we had, as we know, the matched and joint session from 2 parts. One of them was the special session on language technologies, and the second part was the special session on smart e-learning technologies. And the best presentation award goes to Escape Lab, the chemical experiments in virtual reality. Yeah, congratulations. So the authors of these articles will receive the certificates by mail, and the best paper of this conference, which will be published in one of the journals, like Information Technology and Control, or MDPI Computers, or MDPI Electronics, or MDPI Information, will be announced later when we will receive the final decision of the journal's editorial board. And this information will be announced in the conference webpage, and the authors of these articles will be informed personally. So I would like to say once more very thank you for all the participants, for all the authors, for program committee members who reviewed a lot of papers. Thank you for the university, departments for informatics departments, Dean Rita Butkiene, and for support, for Vice Dean Daina Gudonine, and I'm very thankful for all the technical staff, especially for the Walker's team, yeah, which job was perfect, and I'm very thankful for our unexpected today's keynote presenter, Professor Evaldas Vančiukynas. Sorry. So very thank you, and I hope that I will see you next year in Kaunas. In Kaunas, here you can find the call for papers for next year conference, and which should be organized in October, in 14th and 16th of October 2021. So I very hope to see you in Kaunas, and thank you very much. But you should keep a little bit attention because we would like to present our last video. Thank you.